Dr. Indrajit Dey, Dr. Manohar Bhuya, Rishabh Bakul Barua, and Dr. Devasis Dey. Some of these panelists, panel of experts, are going to join as their schedule permits, but be assured that every one of them is going to join sooner or later. And to just give a brief background of each one of these panelists who are going to be here to hear what you have done, what people are doing around us, and give their expert comments. So, first of all, I would like to welcome Abhijan Bhattacharya. Abhijan is a colleague of mine from TCS, and apart from that, he is one of the first indigenous RFC author, RFC 7967. He has got experience and likes to work in the area of protocol and future internet, and has a vast experience in the cross-layer communication protocol stack. And since last 7 years, I know him. He has been working in this area. So, welcome, Abhijan, as a panelist in this PhD forum. Uh, you have done a lot of work to make this program a reality. So, congratulations on that, and welcome to this forum. Among us, we have second Mohit Sethi. Mohit Sethi is a researcher at Ericsson and is a postdoctoral researcher at Aalto University. He has received a Doctor of Science degree in computer science from Aalto University and has got a dual MSc degree as well. Uh, he is very active in IETF and is currently co-chairing the lightweight implementation guidance, which we know as LWIG, LWIG, and is also the co-chair of EAP method update EMU working groups in IETF, and has got an array of papers which he has written, and has got a host of patents. So, welcome, Mohit, and thanks for supporting this effort from India. And we welcome you to this forum. Among us, we are going to have Dr. Manohar Bhuya as well. Manohar is an assistant professor in the Department of Computing Science, Umeå University, Sweden. He joined in January of this year and is attached to the Autonomous Distributed Systems Lab since September 2017. Prior to that, he has been a visiting researcher in the Laboratory for Cyber Resilience in Japan. And Manohar has also worked as a senior lecturer in Department of Computer Science in Assam Kaziranga University, which is based out of Jorhat, Assam. So, a very fine gentleman and a supporter of Internet Society activities since last few years. So, thanks for that, Dr. Manohar, and welcome to this forum. We also are supported by Dr. Indrajit Dey, who is an doctoral researcher in the field of metallurgy and materials, and currently associate professor in MCKV Institute of Technology. He has done his doctoral research from IEST Shibpur, and is again author of uh, more than 30 papers and has filed multiple patents in his name. So, welcome, Dr. Indrajit Dey. Among us, we are also going to have Dr. Devashish Dey. He is a professor in Department of Computer Science and Engineering and Director of School of Computational Science in Macau, which was earlier known as West Bengal University of Technology, and is an adjunct research fellow at the University of Western Australia. Now, it is a matter of pride for all of us that he has received the Shiksha Ratna Award by the government of West Bengal in the year 2019, and his research areas uh, and interests include mobile age computing and IoT. And he has published more than 300 peer-reviewed journals and more than 100 conference papers. So, a very fine gentleman and a learned scholar. Dr. Devashish Dey, you are welcome to this forum, and thanks for supporting this as well.
Thank
Among
you.
us, we have, thank you. Among us, we have got Rishabh Bakul Barwa. He is a budding scientist. He is working in Tata Consultancy Services, is a proud alumnus of SMIT from 2012 batch, and is very young fellow working in the field of embedded systems and robotics, cognitive robotics, and currently he is known as a budding researcher in TCS. And the fact is that he has received 3 patent filing awards, 2 academy awards in just year 2020, and there are still 16 days left in 2020, so maybe he can file a few more. So welcome Rishabh to this forum, and thanks for supporting this forum as well.
Thank you so much, sir.
And we also are going to be joined by Dr. Amlan Chakravarti in another few minutes. Dr. Amlan Chakravarti is heading the uh, computer science in A.K. Chaudhary School under Calcutta University. He is known for his work in the field of quantum uh, and is supporting multiple startups within Calcutta in the field of quantum technology. He is also the chair of one of the working groups on quantum internet in India Internet Foundation, and uh, completely agrees with the idea of this kind of forum, which is an initiative from our side and supports thoroughly. So welcome Dr. Amlan Chakravarti in this forum, and thank you for supporting us. So with this, I'll quickly move to the agenda of the day, which is actually the paper presentation by 8 different groups. So the first group, which is the first paper which is going to be presented, is by Darsin Daimari. He is from Central Institute of Technology, Kokrajhar, Assam, and his paper title is Application of Information Communication Technologies for Smart Library. So, uh, welcome Darsin, and your 15 minutes starts from here. So, Anand, you may want to share his slide deck.
Is Darsin, your slide deck is shared.
Good evening to every one of you, sir. Am I audible, sir?
Yes, you're audible.
Okay. Good evening to everyone, all the distinguished persons here. Myself, I'm Dersin Daimari. I'm a PhD research scholar from CIT. Then I have been supervised by Dr. Amitabh Nag, Associate Professor at the Central Institute of Technology, Kokrajhar. So my paper is Application of Information Communication Technologies for Smart Libraries. So like the information communication technologies has had a great impact on our daily life. And so it has a great impact on the libraries also.
Yes, Anand, next slide, please.
Okay, here, smart library, that is, sir, so I cannot proceed on ahead with myself, I mean, the slide.
No, you will have to
okay,
say
sir,
the next slide, please, and
okay.
then we will.
Okay, thank you, sir. Thank you. So this is the smart library. We used to call it as a traditional library before. Now the libraries have changed with the development of information communication technologies. A library fitted with smart library technology is able to open to library users without being staff. That is, the technology enables remote control of library buildings, including automatic doors, lighting, self-service kiosks, and public computers. This allows the libraries to significantly extend library opening hours, so more people can use the library at times that is convenient for them. So that is what a brief description of about a smart library. Next, sir. Next slide, sir. So here the information communication technology. So I hope everyone knows about it. I don't have to define it again. So here ICT or information communication technology is the infrastructure and components that enable modern computing. The term is generally accepted to mean all devices, networking components, application and systems that combine allow people and organizations to interact in the digital world. So maybe the next slide, sir. Can we proceed to, yeah. So discussion is that recent years have witnessed the explosion of interest in information and communication technology across a wide span of applications from academia to industries. The advanced technologies such as Internet of Things and machine learning are used to facilitate convenient and efficient human living. The Internet of Things can be defined a heterogeneous network with smart devices connected to Internet. The machine learning refers the ability to provide feasible solutions to a variety of problems from prior knowledge of system, network, users, and parameters. So machine learning is a subdomain of artificial intelligence. The integration of IoT and ML is powerful and is said to transform many applications, including healthcare, smart city, smart transportation, and smart library, etc. Together, IoT and machine learning can provide a promising solution for changing the traditional libraries to smart libraries. The change of information needs by the users of the library and the development of smart technologies has an immediate effect to the application of smart technologies to the libraries. That is, the application of IoT and ML has significantly impacted the management, acquisition, cataloging, and circulation of the resources in libraries in satisfying the user's query and their needs. In this paper, we proposed an IoT and ML-based smart library framework where smart end devices collect a large amount data efficiently. That is, machine learning with the help of this collected data develops automated solutions such as prediction of data, date of availability of books, recommendation of books uh, as the users need it. So next slide, please, sir. So here we have various aspects of a smart library. That is, first in a library when the books are purchased. So that is the first side is that acquisition, cataloging, and tagging we do. Then it is processed with the help of RFID reader scanner, then RFID tag. Then all this means which forms a smart library that is OPEC, that is online public access catalog kiosks. Here we have a web OPEC that is the books which are in the library that can be found with the help of online public access catalog on websites. And we have the magic mirror, that is display unit, by which we can know every single activities in the library. So all this forms a part of a smart library, and this is due to the development or the application of Internet of Things and the machine learning. That is, if we do a circulation here, you can see, so here RFID anti-theft security gate, by which the RFID tags are close to a book, then the books are circulated to the students. If any book which doesn't have an RFID tag, then this anti-theft gate gives a call that these books have not been issued to the user. And here the flap barrier, and this is the RFID membership card. The website homepage is there. So mobile application is there. Then we have the drop books. That is the books which are being returned to the library by the users. They will be given taken to a book drop and will be taken to the shelves, to their own shelves. We have the CCTV cameras and we have the sensor lights. The inventory device is there to get the books information, which books are which in the which shelves. So this forms the various aspects of a smart library. Next slide, sir.
Darsin, you have one more minute to complete, and then we will go for Q&A.
Okay, sir. So Internet of Things in libraries. So these are some of the building infrastructure on IoT facility, mobile apps, saving power. And so this identification and recommendation of books, then kiosks. Next slide, sir. So this is the RFID framework in library. Next slide, sir. This is the basic architecture of IoT in library. That is the how the architecture of a IoT is placed in the library. Next slide, sir. So integration of IoT and ML, that's machine learning in smart library scenario. That's it. Just a given a scenario of that. Next slide, sir. Here, a study was conducted, that is book ability prediction model for library management system. So here we found we have used random forest support vector and neural network algorithm systems to find out. We have found about like 87% of data that can be said that if any book availability is there, that is a prediction for a book that a users can have on a future date. That means if the book will be available for them or not. So that study was being conducted. We had the data of about 5,000 data, and we have the testing data about like a 25% testing data we had. Then the training data were about 75%. From there we got like 87% data. And so this has been done. Next slide, sir. So here are some of the challenges which can be found: fund for implementation, smart building, security, extraction, power, energy, reliability, fragmentation. Next slide, sir. So in conclusion, so although IoT began simply as a consumer phenomenon, at numerous fields like smart cities, parking, home, smart home, etc., it has significantly impacted the libraries as smart libraries. The fast growing IoT have not been left out from implementing in libraries. So IoT poses a new design and development dilemma, fast and easy. We need to think on IoT application for its implementation in libraries for real-time results in acquisition, cataloging, circulation, and management. Recently, librarians have struggled to understand the relationship to the new breed of IoT application in libraries, which would connect the users, the documents, books, and the library professional in a smart library. Next slide, sir. So this is the overall of my paper. So thank you so much. Thank you for your patience, for hearing. Thank you so much.
So thank you, Darshan. I'll go to the panelists. Does any one of the panelists have a question for Darshan?
Thank you for your nice presentation.
Thank you, sir. Thank you.
And it is a wonderful library I have visited last year.
Thank you. Thank you.
But I have just one question.
Yes,
there
sir.
Is, so what kind of IoT communication technologies means backbone wireless network you are using? Is it totally internet kind of thing, or what is a frequency bands or backbones are there?
See, we have been trying to do with this one RFID. That is the RFID wireless technology.
Okay.
Okay.
But are you giving this facility to your hostels?
Yes, sir. So like hostels, that prediction is always it's going on. Like hostels, they need to get the prediction of the book, or that means the books are being predicted. Like if you want any books, we will be giving the facility to the hostels in the campus itself. Whoever lives in the campus, so those facilities are being given to the students.
Okay, thank you.
Okay, Darshan, thanks. Thanks, Dr. Devashidev, for your question.
Thank you, sir.
We move to the second presentation. It is by Samarjit Roy. He is from Department of Computer Science and Engineering from Macau, and his paper is titled "An ICT-inspired music analytics framework on Internet of Music Things."
Hello, sir. Good evening. This is Samarjit Roy.
Go ahead.
Sir, may I please present with my slide, because there is a lot of animation. So again and again, Next place is a very difficult task for you only, and that's why I'm going to request you. So
Anand, is
if
it
you,
okay to pass on the sharing thing to Samarjit?
Sure, we can do that.
okay, sir.
Okay, please.
Thank you very much.
Now you can share.
Okay, sir. Just a minute, sir. Please share screen. Desktop. Is this visible, sir, to everyone?
Yes.
Okay, fine. Okay, good evening, all the respected panelists and the experts from the various domains and some discussions on the esteemed forum of IPhone and IIW. Myself, Samarjit Roy from Maulana Abul Kalam Azad University of Technology, West Bengal. Hope you are doing well during this pandemic situation. And right now I am going to discuss our presentation on Internet of Music things, basically. So before going to the presentation on Internet of Music things, I am going to share with you some research outline where from the Internet of Music things can come. The first one is object-oriented music analysis. Here, the object-oriented music analysis, we have patterned and we have modeled the paradigms under the UML-based paradigm, UML-based background, such as polymorphism, inheritance, generalization, specialization, aggregation, and encapsulation, like that. Then we have modeled this musical phenomena in the perspective of Indian classical music with the modeling tools, some of the specific tools like Petrinet. Then we have shifted to this paradigm to the evolutionary music computing and intelligence system. Here we have used the emerging techniques of soft computing and intelligence systems and artificial intelligence, as you know. Then we have found out the music information retrieval. Next, we have found our emerging paradigm, the Internet of Music things, firstly, and from here, the Internet of Music things in ICT paradigm, in ICT phenomena, we have analyzed this, we have illustrated this into the musical pattern recognition. So today's discussion of today's domains of discussion have been categorized in these following points. First one is the Internet of Music things, the actual phenomena where the edge cloud computing based paradigm has been taken into the consideration. Next one, we are going to discuss today on entropy aware ambient Internet of Music thing analytics, where the music information fusion has been incorporated with these challenges. Next one is a very emerging paradigm right now in the advanced technologies with the DU computing, where the DU and IoT, how this has been incorporated with the systems of Internet of Things, there should be illustrated. And next one is where IOMT, I mean Internet of Music things, have impressed the society with the musical phenomenon such as the music recommender systems, on the challenges in the information and communication technologies, and so forth. So in the first, I am going to elaborate the Internet of Music things in the edge computing paradigm, where the crowdsourcing, the mobile crowd sensing paradigm has been taken into the consideration. The first one is the framing of Internet of Music things. Next one is the framing and modeling of the music crowd sensing architecture with the opportunistic music crowd sensing. Next one is the analysis, the system analysis, basically based on in the context of the transmission and service time and latency. Next one is power and energy. This is the overall architecture of Internet of Music things, which we have developed earlier in the stage of the research on Internet of Music things. Here, the 4-tier architecture have been incorporated. The first one is physical tier, where all the sensor devices and the musical environment have been taken into the consideration for evaluating the challenges. Next one, we have gathered this sense data, I mean sensor data into the edge devices. The local computations have been performed there. and then we have stored and computed in the public domain, that is in the cloud tier. And from the cloud tier, the user applications, we have developed some application scenarios where the end users can access the data and the analyzed informations from the cloud. This is the overall IOMT architecture. And this is the flow of activities where the sound source, from the sound sources to the music crowd sensing application. This has been provided in the step-by-step approaches. Next one is the analysis procedure, where the service and data transmission time has been evaluated through these equations, and the results have been in the following. This is the energy consumption results. By this equation, we have computed the overall system energy. Now, this is the comparative analysis, where three types of domains we have incorporated with these systems. The first one is edge to cloud, where the data at first transmitted to the edge, and then we have stored in the cloud. Next one is the cloud via edge, where the local computation and public computation both have been performed in the cloud stages, in the cloud computing devices and data centers. And last one is where the conventional paradigm, where the edge computing have been started. Although we have taken some results in this scenario, using this scenario, that our projected scenario, that is PH to cloud, I mean power edge to cloud, this have been given the efficient result than the other conventional paradigms. Next one, when we are going to elaborate the application scenarios of the music in the context of music information fusion domain, the Internet of Music Things, how the challenges have been performed and taken into consideration. The first one is we have framed the humanized IoT-aware music information fusion schema. Next one is we have framed the edge cloud computing archetype for the music information schema in the humanized IoT aware music Internet of Music Things. Next one is we have evaluated the latency and power dissipation. And lastly, the information and system entropy have been taken into consideration for better evaluation of system efficiency and stability concern. This is the overall system architecture, where the sensor data, as usual, the Internet of Music Things domain, the sensor data collected all the data and taken and transmitted to the edge devices for the data pre-processing and computations. Then lastly, here we have used the IoT analyzers. IoT analyzers means the open access IoT analyzer, that means ThinkSpeak of MathWorks, we have incorporated in the system. This is the flow of activities, overall system phenomena, where the data has been transmitted from the sensing devices to the end users, and how the end users can be capable to receive and sense all the informations from the system. This is the evaluation strategy. First of all, the music information entropy. By this equation, we have evaluated the entropy of our sense data in this real-time data processing. Next one is system entropy. Then we have computed and evaluated the system efficiency. That's all for the better evaluation and the system stability perspective. Last one is the emerging topic, where we have been going to proceed with the due music challenges. That means the Internet of Music Things in due computing paradigm. Here, the crowdsourcing based approach has been taken into the consideration. All we know what is crowdsourcing or this. So crowdsourcing based framework in the due music computation have been taken into consideration in this paradigm. Here, the crowdsourcing based framework we have modeled. We have measured the system efficiency and the system latency and and overall the system procedures for designing and modeling the energy efficient system modeling. Here is the crowdsourcing based procedure for the due music architecture, where crowdsourcing, as we know that crowdsourcing performed in the in this procedure. Here the divide and conquer policy have been taken into the consideration, where the smart devices have gathered and sensed the data and perform the several tasks and proceed for the services to the end users. Here the 5-tier architecture we have given. This is the overall architecture of the proposed DU Music crowdsourcing based Internet of Music things. Here, the 5 layers have been taken into consideration, and DU has been kept in this system. DU has been modeled due to as the local repository where the local computations and the data pre-processing tasks can be performed. This is the overall activities, overall system activities where the DU music can be performed to the system. This is the evaluation strategy started with the service time analysis. This is the service time of our real-time sensed data through the system. Then we have performed the transmission time. Here the overall system energy dissipation have been evaluated. This is the energy dissipation architecture, and we have compared the conventional cloud computing framework with our projected crowdsourcing based DU computing paradigm. This is the comparison results. So how we are going to discuss shortly in a short that how Internet of Music things, our projected paradigm, can inspire or can impress the next evaluation of the information and communication technology domains. And we have named this system as the iMusic, where we have contributed in this system. First of all, we have modeled the topic model inspired iMusic framework. Then we are going to elaborate the system designing strategies of the music profiling in the context of our music platform. Then we are going to discuss in future the music representation learning, then session specific music exploration and the music recommendation. This is the overall architecture where we are going to discuss in future on the iMusic platform, iMusic phenomena. Here the overall system architecture have been taken. First of all, the music sources where from the music can be gathered or sent to the sensors or real-time smart devices. Then how will we represent the features? Next one, how will we store in the databases? Next one, the visualization part. Next one, for the better music recommendation to the end users or the listeners, music listeners, then the rating prediction should be taken into the consideration to better outcomes and the popularity. And this is the overall architecture where we have incorporated the deep learning framework and the basic representation learning frameworks in this domain. And these are our basic scope for the future researches. Some of them I have been mentioned here. In the IOMT framework, the crowd sensing architecture that we have been already discussed, the multi-level sensor fusion, this should be elaborated in the future. In the DU music paradigm, the bandwidth allocation and virtualization and the participatory crowdsourcing based paradigm, although we have to take it into consideration in future. In the ICT paradigm, in the music teaching learning process, we are going to discuss the GAN-based, I mean generative adversarial network-based music pieces and music factorization and recommendation systems. These are our some list of publications in this domain in the Internet of Music things. We have published some papers. So
Thanks,
thank you
Amarjit.
very much.
So panelists, over to you. We do have room for 1 or 2 questions. So anyone has a question for Samarjit?
If no one has a question, then I can ask one.
No,
Sure,
you
sir.
can go ahead, Abhijan.
Yeah. So when you measure the latency and other performances,
Yes, sir.
I mean, what was the benchmark and what is the protocol that you have used, the communication for between all these? Did you use any standard stack or anything else?
Sir, actually, based on the data, based on the sensor data which we have sent to the sensor devices, here from the computational task, I mean the data transmission time have been kept in the system, and then we have analyzed this real-time data through the sensors to the edge devices, the transmission time and the latency, and overall system.
Yeah,
And
I understand that, but what I want to know is that when you are sending from the, say, when you are doing the crowd sensing, so
yes,
from there you are sending to your DU, then edge, cloud,
yes,
whatever. So multi-tier, right? So while doing this communication, so what is the I mean, are you doing this communication physically? I mean, if between two systems, in that
yes,
case,
sir. Of course,
what is the
physically. This
protocol?
is real-time processing, real-time data
What is the
processing.
protocol that you have used? You must have done some socket communication, or you have done through local over the MAC, I mean layer 2 communication, or what have you done? I mean,
This is an application level scenario where we have communicated through the socket. This is exactly not in the socket communication. This is the benchmark we have set that we have estimated the real time basically.
no,
So
no,
there
I
is
understand that. What is the communication mechanism between the two, between the multiple devices? That is what I want to know. I mean, there must be some communication mechanism, right? Otherwise, how have you transferred data from one machine to another machine? So that is what I want to know.
it's
What
a
is the
simple
communication mechanism?
the network communication we have incorporated with these
Yeah, yeah.
systems.
So if you could tell me that what was the exact communication protocol that you have used over the network? There are several protocols, right? So that would have been interesting. So that is it.
Okay, sir. Sure. Thank you.
Any other questions for Samarjit?
Hello, Rishabh here.
Yeah, Rishabh.
Samajit. So yeah, so it is a quite interesting topic, and your presentation was quite interesting. So what I wanted to know is that so you have used a tiered architecture. So first IoT for the
Yes, sir.
IoT based systems. So you have used a edge kind of a layer, then you have used a cloud kind of a layer. So, so what kind of data is being actually extracted at the very basic level, which are being actually analyzed in the cloud and the edge?
Yes, sir. The frequency we have measured at first. Initially, we
so
have
the,
taken the frequencies.
okay,
of
the
system.
frequencies are being taken. Okay,
Yes,
and
yes.
so is it something like that? So when the computational requirement is heavy, you are offloading it to the cloud, and else you are doing it in the edge, or
Yes.
what kind of a procedure you are using to offload to the cloud? Means
Yes,
what
sir.
kind of things are
Whenever
offloaded?
we have taken the sensors, there are some multiple microcontroller devices are there. So
Okay.
like Raspberry Pi or Arduino Uno, Arduino Duo, like something.
Yes.
Then we have taken this data from the microcontroller in the to the edge devices, the local edge devices. Then
Right.
we have performed the local analytics tasks.
Okay.
And then we have taken into the cloud. So at first, the local pre-processing, data pre-processing have been taken into the consideration in the edge devices at first. Then we have transmitted to the cloud for the end user services.
Okay. So so the amount of data processed is same in edge and cloud. Only
Yes,
difference
yes,
is
yes,
only
yes, yes.
different. Okay. Okay. And in cloud, are you using any predefined tool or framework, or it is just a distributed setup you have used
No,
in
no.
cloud?
At first, we have used the distributed framework here.
So means you have not used any
Then
predefined.
we have analyzed according to the data or according to our requirement of the model.
Okay. 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 Thank you. Thank you so much.
Thank you very much, sir.
Thanks, Rishabh, for your comments, and thanks, Samarjit, for responding to
Thank
them.
you, sir.
So you may want to get in touch with the panelists later on as well.
Sure,
All
sir.
of you are marked in the same mail, so please carry on the communication there. With this, we move to the third presentation for the day, which is by Atanu Majumdar. He is presenting on energy-aware real-time scheduling for heterogeneous reconfigurable cloud platform. Atanu, over to you.
Okay, so good evening, everybody. So myself is Atanu Majumdar. Currently, I am a research scholar of AKCSIT School of Petroleum Technology of Calcutta University. I am working under the supervision of Professor Amlak Chakraborty. So today I am going to present some research topics that is, actually I'm not able to see this screen.
It is coming up, Atanu.
Can I share my slide? Because I have changed one slide little bit. So
Anand, can you give the rights to Atanu, please?
Sure, he can share the slides.
okay, thank you, sir. So is it visible now?
Yes.
Okay, thank you. So my research topic, the idea is about the energy or real-time shielding for heterogeneous configured cloud platform. So here is the today's agenda. I will start through introduction, then followed by the motivation and the objectives of my research work. Then I have defined one problem related to my work, then followed by the related work, the methodology I have followed for solve the problem, and the implementation and the resolution, and finally the conclusion. So here we have choose field propagator FPGA as a reconfigurable system. So that actually gives the benefits of flexibility of general purpose processor and the efficiency of a dedicated hardware. You can see from the left-hand figure that general purpose processors have higher flexibility as it can be reconfigurable at runtime, but the performance is very much low. In case of ASIC, application-specific integrated circuit, we can't reconfigure at runtime, but the performance is very much high. So as a trade-off, we choose the reconfigurable platform or FPGA that gives a moderate performance and also gives high flexibility. So here we have chosen the cloud platform, and in cloud, the task acceleration is a bigger major issue, and we can resolve this issue by choosing an FPGA as an accelerator engine. Nowadays, cloud computing is consuming huge amount of energy, and that affects in global warming or in our environmental changes. So we need to minimize the overall power consumption. So as the FPGA, it works with low power computation platform. In a Microsoft Catapult project, they have used FPGA in Bing search engine, where it has been observed that due to the 10% growth of the power, the performance can be increased up to 95%. So here is some of motivations of my work. As I told that acceleration task processing in cloud is a big issue. So FPGA can be give a suitable choice for using as an accelerator engine to resolve such kind of issues. In cloud, there are wide range of tasks has been execution has been performed. So we need to develop some online or offline energy sharing strategy so for heterogeneous cloud computing platform so that it can handle such wide range of tasks. Assigning the task to the proper processing elements not only minimize the execution time or make spend time, but it also ensures such other relative objectives such as it enhances the resource utilization, maximizes throughput, minimizes the task rejection, overall ensure the quality of services, and also help to reduce the energy consumption also. Including the FPGA in the cloud data center, how virtualized technology actually work with the FPGA. So we need to analyze the effect of such technology in the such heterogeneous systems. And last one is the main issue of IoT and fog is to optimize the energy consumption. So these are my objectives. First is task handling. As I already told that wide range of tasks are executing on cloud platforms such as real-time, non-real-time, periodic, aperiodic, sporadic, mixed critical nowadays is considering a lot of attention. So our objective is to explore the scheduling approaches for heterogeneous configuring cloud platform that cloud can handle efficiently such wide variety of tasks. Second option is the resource utilization. We need to assign the task to the proper resource element so that it can minimize the computation time, load balancing, and power consumption also. Hence, it actually enhances the resource utilization so that the rejection of the task can be minimized. And last one is the energy optimization. As I told that the higher complexity of tasks that perform better in hardware rather than in software. So acceleration of the task execution in software may produce better throughput, but it consumes a lot of energy. So overall, we find a trade-off that will give a moderate performance and also the low energy consumption. So develop an energy optimization for that. We need to develop an energy optimization particularly to handle real-time as well as non-real-time static and dynamic tasks also. So design energy efficient scheduling techniques for heterogeneous multiprocessor real-time systems. So here I describe one of the problem of my research work. Here we considered the task as a real-time periodic in nature. So a set of tasks arrive for execution in cloud, and here we see in the figure that the real-time scheduling strategy that actually helps to deploy the task in the physical server. So considering the two
You'll
cases
have to
that
speed up.
it should, as it is a real-time task, okay, it it should maintain, it should can meet the deadline as well of the task because it's a real-time task, and the overall power consumption of the system should be minimized. Here we have considered two types of processing elements. One is the FPGA and one is the CPU in cloud server. Okay, and of course, we considered that the processing element number should be always less than the overall task number. So here is some related works in the topic. These are some state-of-art techniques that we have compared with our proposed methodology. The methodology we have followed here that we have considering FPGA and CPU. So FPGA actually supports the hardware version of the task execution, and CPU it supports the software version of task execution. So in the figure we have shown that HDL high definition language is being used to implement the hardware version of task, and system C programming is being implemented to deploy this software version of task. So here the partitioning of these tasks is important. So and the scheduling mechanism that ensures whether the task can be feasibly scheduled to this software or hardware-based platform, because if it cannot perform or meet the real-time deadline, it should reject the task, and the task allocation to the proper processing elements. It also helps to minimize the energy consumption also. So first we have experimented done on the simulation-based platform that CloudSim has been used, and then we have developed a real simulation testbed using the FPGA. So here is the energy model that we have followed. I'm not going to elaborately discuss this slide. So here's the model for measuring the power consumption or energy consumption for this proposed work. So here is the strategy that we have discussed. So we have used the real-time scheduling strategy. One is time partitioning based scheduling strategy we have followed. So time partitioning based scheduling strategy that ensure that the system can efficiently handle the real-time task such that the deadline of the task is not jeopardized. And another portion that real integer linear programming is formulated for assigning or allocation the task to the proper heterogeneous processing element. So here we have shown the graphical presentation of the FPGA board that is Zyneq ZC702 SoC in the right hand, and here the architecture of the PSPL, that the software part, the ZineQ board consider two type of elements. One is ARM Cortex processor and another is FPGA logic. So ARM Cortex processor is located in processing system and FPGA logics are in programming logic. So here we have connected the multiple FPGA board or FPGA SoC to the host PC through PCI communication port. The
Atanu,
XC
I
bus
think
has been.
Atanu, I think we need to fast forward a bit so that we can have.
So I
one or
have
two
to slide
questions.
more only. It's already done. Already have it complete. So we have used the XC bus protocol, XC bus for communication using PS and PL, and we have used the standard benchmark EPFL benchmark as a set of tasks. Here I have shown the resource utilization of the components of the FPGA boards and in what is the energy consumption of ideal case or execution or the deconfiguration of power consumption have been shown for ARM and FPGA for both the cases. And here is the sum of the results. We have shown that the proposed strategy has been evaluated with the two parameters. One is the service rejection rate and one is the energy consumption. So we have compared our proposed techniques with some state-of-art techniques. So here we can see that the energy consumption can be minimized up to 23% than the other state-of-art techniques, and the rejection rate is minimized up to 19%. And the measurement of the energy is done in kilojoule, and the computation time is measured in this second. And here's the conclusion. So in this work, we have presented the methodology for task allocation of FPGA-based heterogeneous cloud server so that we can minimize the energy consumption. And we have implemented and evaluated the algorithm in simulation-based experiment on CloudSync tools and also in multiple FPGA platform. So that result demonstrated that the proposed shielding strategy is able to achieve our objectives.
Thank you. Thanks, Tanu. So we do have around 1.5 minutes left from your session. So any brief question and a brief answer, quick response from Atanu. Any of the panelists?
Yeah, this is Avijan here.
Yeah, Bijan.
So so one thing would be to interesting to see how the system reacts to actual, I mean, when it is overloaded with connections from multiple peers. So how the system actually works. So if you are able to do some practical experiment on practical systems in future with several thousand nodes.
Yeah, we have done some physical experiments on Zinc SoC board. So here what we observe that if the system is overloaded, if there is no enough such slack space remaining for task execution, the task will be discarded. And in overload situation, the system energy consumption also is very much high. So we also take the consideration that the load of the system should maintain. That should not be an overload system. So we will migrate the task from one system to other so that the load can be minimized.
No, these are some generic things that people will any cloud system will do in general. So we need to see that how much efficiency you have gained using this system. I mean, what you say overload in this system, so maybe other systems might be overloaded at a much lower level. So whether that is a reality or not, the switching, the way the switching in
Bijan,
the system. Yeah, sure. Let us move on. Yeah.
No,
we'll discuss it. We'll take it
later.
offline. Yeah.
Okay.
Thanks, Atanu, and thanks, Avijan, for your comment. We move to the next presentation. Anurima Tarafdar. Anurima, you are there, right?
Yes, sir. Sir, can I please share my screen?
Yes, you can. You will get the access rights, and your paper is on resource management in a cloud data center, considering energy efficiency and performance resource management. So, Anurima, over to you.
Okay, sir. Thank you.
Please, you can share your screen.
Good evening, respected sirs, all the eminent people in the panel. I am Anrina Tarafdar, a PhD research scholar and UGC NET JRF in Department of Computer Science and Engineering, University of Calcutta. I am giving a presentation on the topic Resource Management in a Cloud Data Center, considering energy efficiency and performance. At first, I'll briefly introduce the topic and then give a brief discussion about 4 important aspects of resource management, that is virtual machine consolidation, task scheduling, workflow scheduling, and formulation of suitable power consumption model for servers in a data center. Cloud computing enables on-demand provisioning of services in a pay-per-use manner. Cloud service providers have built data centers across the world that contains numerous physical machines, servers, or hosts. Using virtualization technology, we can create VMs on these physical machines, and the tasks of users are executed on these VMs. These large-scale data centers consume a huge amount of energy, that is electrical energy, which has a negative impact on the environment and also increases the operation cost of the cloud service providers. In cloud, it's very important for the users to have good performance of their services. At the same time, reduction in energy consumption is important to promote eco-friendly cloud computing and also reduce the operation cost of the cloud service providers. Thus, we see the importance of both energy efficiency and performance in cloud. Now, different techniques are being used to promote energy efficiency, like using renewable sources of energy in the data center, using efficient cooling techniques. Now, one such important technique to promote energy efficiency in cloud is resource management in data center. Now, as discussed, the cloud data center has numerous physical machines, which provides resources in the form of processing power, memory, etc. Now, these servers are one of the main energy consumers of the data center, and effective management of these servers' resources will help to reduce energy consumption. Moreover, performance of tasks and VMs also depend on their suitable allocation to resources. Thus, effective management of resources in cloud data center is very important. In this presentation, I will discuss 4 popular approaches of resource management. For each of the 4 approaches, I will discuss some existing works and possible future works. Firstly, efficient virtual machine consolidation in a cloud data center. In data center, it has been found that the VMs are actually dispersed across the physical machines, which results in poor resource utilization and high energy consumption. Effective consolidation of the virtual machines on the physical machines will reduce the number of active physical machines and also results in low power consumption. In this respect, an ILP-based work has been done where we try to minimize the number of active physical machines by keeping into consideration the resource constraints. An existing work in research considers this VM allocation problem as a bean-backing problem where they try to consolidate the VMs on the physical machines. The VMs are considered as items and the hosts have been considered as bins. They have used a modified best fit decreasing algorithm for VM placement. VMs are allocated to the hosts that provide the least increase in power consumption due to allocation. A CPU utilization-based power model has been used, and simulation experiment with Cloud Sim shows the effectiveness of this approach. Now, study of this existing work helps us to make some observation. VM consolidation definitely helps to reduce energy consumption, but aggressive consolidation of VM affects the performance. Moreover, VM migrations are associated with some overheads. In existing works, we see that VM migration is initiated as soon as a host is found to be overutilized or underutilized. But in cloud, we know that the nature of workload is very dynamic or variable. So immediate initiation of VM migration as soon as a host is found to be overutilized or underutilized does not seem to be very appropriate. Also, consideration of a homogeneous data center is not very applicable in real life because we know in real scenario, the VMs and hosts in a data center have various resource capacities. Thus, an effective virtual machine consolidation approach is important to reduce energy consumption, at the same time reduce the number of VM migrations and overutilization of hosts in data center. Next important approach of resource management is task scheduling. Tasks submitted by cloud users are scheduled on VMs. Some scheduling approaches are there which try to optimize one of the performance metrics like monetary cost, energy, etc., but they do not sufficiently consider energy and make span together. Moreover, properties of host are also neglected during task scheduling. Thus, we need to propose a task scheduling approach that keeps into consideration both energy as well as make span minimization. Moreover, applications like those related to healthcare application, healthcare domain, as well as IoT, financial transactions, they are associated with timing constraints or deadlines. Thus, for them, deadline satisfaction is also very important. The problem becomes even more challenging in case of workflows where there lies interdependencies between tasks. A workflow can be represented by a directed acyclic graph where the nodes represent the task and the edges show the data dependencies. The tasks of the workflows run on the VMs deployed in the host of a cloud data center. In this case, effective scheduling of the workflows has to be done considering both considering energy, make span, as well as monetary cost. Because with respect to the cloud service provider, energy consumption reduction is important. On the other hand, with respect to the users, make span and monetary cost minimization is imperative.
Anurima, we are not able to see your screen.
So you're not being able to see the screen. So now is it visible?
No, it just went off right now. So you may want to.
Please
Yes.
reshare.
Yes, sir, once again. So is it visible? Is it visible now?
Yeah, visible.
So will I start from this slide or previous slides?
No, you start from here only, but be a little fast.
Yes. Another important approach is formulation of suitable power consumption model for servers in a data center. Servers are one of the main power consumer of data center, and power consumption model of server plays a very critical role in energy management because a power model helps to estimate the energy consumption of server using which resource scheduling decisions can be made. Now, in research, it shows that the CPU is the main power consumer of the server, and there exists a linear relationship between power consumption of host and its CPU utilization. A popular CPU.
Anurima, we have lost your screen again.
Oh God.
I think you have signal problem.
Yes, I think so.
Your network problem is there. I think better the organizer can project the.
Yes, sir. Then maybe
It will
that
be
would
better.
be better. Yes.
Because Anurima has signal problem.
Yes, sir. I've stopped sharing.
Anand, can you share it?
Yes, I'm doing.
Sir, I've shared the revised presentation as a last mail. You can get it from there. Actually, I added one slide over there. The results.
Doesn't
section.
matter.
Okay, we just need to be aware of the time. So,
Yes, sir.
does any panelist have any questions in the meantime for Anurina?
So how you are measuring the power? Have you done any experiment with power measurement?
Yes, sir. Actually, so far we have done on a simulation-based environment cloud sim, but in future we want to do it in realistic scenario. So far we have done a VM consolidation approach that I will be discussing shortly, and I have done it in cloud sim environment. The power model that I've used is CPU utilization-based power model that I have presented over here. So please, can you? Yes, sir.
Anand, go to slide 18.
Yes. So the previous one. Yes, another important CPU utilization-based power model is this linear model that has been presented over here. The data of real spec power benchmark has been presented over here we see that if the CPU utilization values are given, and based on which the corresponding power consumption of the servers can be estimated. Like over here, if CPU utilization is around 45.5, then putting that value in the power model, we can estimate the power consumption of server. Also, a popular power model is based on DVFS, dynamic voltage and frequency scaling, where the power is based on the supplied voltage as well as the frequency of the processor. Next slide, please, sir. Although the CPU utilization-based power model are very popular and well accepted in literature, but a more accurate power model will further help in improving energy efficiency. Thus, an important objective is to design simple and accurate power consumption model, taking into account different resources like memory and others, because it has been found that after CPU, the main important power consumer of server is memory. Next slide, please. Having discussed the different important approaches of resource management in cloud data center, I would like to discuss our work with respect to efficient virtual machine consolidation in cloud data center. Now, we have considered three important sub-problems of a VM consolidation approach in cloud. Firstly, identification of overutilized and underutilized hosts in the data center. Thereafter, suitable selection of VM for migration from them. And finally, placement of these VMs on other hosts. At first, we identify, and for each of these three approaches, we have proposed suitable approaches. At first, we identify the overutilized hosts in the data center, select VM for migration from them and place them on other hosts. Then underutilized hosts of the data center are identified. All the VMs are selected from them and placed on other hosts of the data center, and the underutilized hosts are then placed to sleep mode to reduce the energy consumption of the data center. Now, for identification of overutilized and underutilized hosts, we have used a Markov chain-based prediction model. This prediction model is used to predict the CPU utilization of the host in future, based on which the decision of considering the host to be overutilized or underutilized are taken, and subsequent VM migrations are performed. That is, for a window period of time, we perform prediction, and if it is found that for maximum time period in this window, the host is predicted to be overutilized or underutilized, only then the VM is considered to be overutilized or underutilized. Thus, immediate initiation of VM migration is not considered. Our results show that this approach significantly helps to reduce energy consumption and also reduces the number of VM migration. Next slide, please, sir.
I think, Nurina, you will have to stop here because we are just left with a few seconds.
Sir,
but considering the
sir,
problems, I'll give you another.
Yes, sir. The results were actually, I sent the revised presentation, but the possibly it could not be included over here. Actually, the result sections were there. Okay, so never mind. I'll conclude it. Thus, we can conclude with a brief summary over here that we have seen that reduction in energy consumption of servers of a cloud data center is very important, and servers are one of the main energy consumer of the data center. Thus, an important approach used in literature is energy efficient and performance aware resource management in cloud data center. In this regard, we have made some progress and done our work with respect to VM consolidation approach. In future, we want to consider some other aspects of resource management like workflow scheduling, task scheduling, and power consumption modeling of servers. Thank you, sir.
Thanks. Any question for Anurina? A brief question. We should be able to handle.
Manohar here.
Yes, sir. Yes, sir.
Thank you very much for your presentations, and I think it's power consumptions in data centers is a quite interesting problem. But I'm like a little bit of might be orthogonal to the problems, but I'm not much more sure that's what's exactly your contributions you made in this work.
Sir, actually, I have done a work on VM consolidation where we have divided the VM consolidation problem into three parts. That is identification of hosts, overutilized, underutilized, as well as VM selection and VM placement. And for each of these three sub-problems, we have proposed some approaches. Like for VM consolidation, identification of overutilized, underutilized hosts, I've used a Markov chain-based prediction model where we analyze the utilizations of each of the VMs for a long period of time, and based on the history data, Only then we consider, based on the history data, we predict for a window period of time what will be the future CPU utilization of these VMs and hosts. If in just when we put some thresholds like CPU thresholds, if this threshold is crossed, only then we consider that the host is overutilized or underutilized and select VM for migrations from them. But we know that the in cloud the workload varies. Thus, immediately there's a certain spike in the utilization. At that moment, it's not right to consider that this host is overutilized and immediately start VM migration from them. Better we use a prediction approach that we have used is Markov chain-based model. And using that predicted data, if it is found that for maximum time in future, the host is overutilized or underutilized, only then we consider the VM to be host to be overutilized or underutilized and perform prediction. This approach has helped us not only to reduce the number of VM migrations that I was unable to show with the results, but also helps in promoting energy efficiency, because it has been found that maximum time in the data center, if immediate VM migration is initiated as soon as the thresholds are crossed.
Anurina, we'll have to stop here. I am so sorry for doing this, but I'm little strict on time because we have a lot to cover. So
yes, sir, yes.
Manohar, I am not sure whether your answer.
No, I mean that's one single statement that what I feel it should be like, when you do like such kind of experiments or like such kind of works, I think it should be very good that like simulations, and at the same time you have a test bed experiments to realize that what exactly really happened in the real test bed and rather in simulations.
Yes, sir,
Because
yes.
there's lots more difference in simulations and if you do in real-time experiments.
Yes, sir, we agree, sir. Actually, we have completed the simulation in Cloud Sim, and next is our next work is only on the real scenario, real data center. That is our next work.
Thanks,
Thank you, sir, so much.
Thanks. Please connect with Manohar offline, and I'm sure he will be able to guide you.
Yes, sir.
Thanks, Manohar.
Thank you so much.
Next is blockchain-based or decentralized trustworthy network for public healthcare. We have multiple authors here, Asmita Biswas, Bipasha, and Deep Subra. So who is going to present? Deep, Bipasha, or Asmita?
Yeah, good evening, sir. Yes, I myself, Bipasha Mahato, and one of our MTech students, Miss Ashmita Biswas, will present this. So,
Okay,
please.
Asmita, go ahead. Your time starts now.
Okay, so please share the slide. We can't see this.
Anand, please share the slide. Anand, can you please share the slide?
Yes, I'm sharing. Is this shared?
Yeah, it is there. Please
Yes,
put it
yes,
on full
yes.
screen mode.
Yeah, thank you for sharing the slide. So a very good evening to all of the respected panelists and attendees, other attendees. Now we are present one of our collaboration research work on blockchain-based decentralized trustworthy network for public healthcare. It is a collaboration between India and Europe and under the guidance of Dr. Deep Subra Guharai. So in this regards, next slide, please. Thank you. So in this regards, we will first introduce the current scenario of pharmaceutical industry and then steps of pharmaceutical supply chain. We will come to the next to the public healthcare domains and with the shortfalls to implement a uniform PSC platform in the particular implementation area. Then after that, Ashmita will give you a brief introduction of blockchain technology. Then we will see how the blockchain system architecture can give you a solution in the public healthcare management system. And then few related research works and other case studies will be shared with their limitations. Next, we will provide the key solution through our proposed architecture. Lastly, we will discuss some key challenges faced during the implementation of the proposed architecture. So next slide, please. So here come to the introduction about the pharmaceutical industry. Basically, pharmaceutical industry is responsible for the medical-oriented research, infrastructure development, medicine and other medical equipment development, and instruments like DP machine, USG machine, etc., and distribution of medications overall among to the patients and other users. So here we can see some pharmaceutical industry revenue generation graph in the right side of the slide. So there we can conclude that the market has already experienced significant growth during the past 2 decades, and pharma revenue worldwide totaled 1.25 trillion Markin dollar in 2019. So overall, pharmaceutical industry is one of the fastest growing, vast and complicated business model, and worldwide industry ranking is 2. So next slide, please. So here we can see the steps of the business model pharmaceutical supply chain, where from the raw material purchase to the distribution of end products like medicine to the customers are there through processing, guideline maintenance, manufacturing, and other clinical trials, documentary checking, packaging, and ultimately the distribution to the customer. So in the right side of the slide, we can see a well-known pharmaceutical chain which is achieved by the Sun Pharma from the supplier into the patient consumer end. Here we can see the raw materials has purchased from the supplier. Then the Sun Pharma produce their medicine into their factory, and then they distribute them to the wholesaler and distributors from parallel way like pharmacy, retailers, and hospital to the patient and consumers end. The next slide, please. So here you can see a vast and complicated network of Indian healthcare system, where there is 2 domain. One is public and another one is private. So Ministry of Health, Ministry of Defense, and Ministry of Railways collaboratively they giving us service of medical healthcare throughout the last many decades, and they are providing their service to the rural and urban areas patients through state and central rules and regulations. And also there is some private procedure for non-profit and for profit areas, and they are also maintain the state and central government rule for the public healthcare domain, and they are giving their charitable trust and other non-government organization running clinics and
Can I request you to go to the
yes
technical problem area?
Okay, yes. So next slide, please. So here is the shortfalls of the pharmaceutical supply chain due to the vast and complicated network. So the scalability is one of the problem where due to that the patient could not get all the facilities which they supposed to make out from the several central and state government activities. And there are also fault tolerance and reliability related issues, data and other service security, functional security issues, and data production and complicated proximity issues. So for that, we have decided to introduce blockchain technology in this case. So for that, I would like to request Ashmita to please continue with the remaining slides.
Good evening, everyone. I'm Ashmita Vishwas. So I'm gonna discuss about remaining slides. So blockchain technology is a disruptive technology, and it performs data transition from client server to a secured system. It is a timestamp ledger associated with data, cryptographic hashes of current blocks and hash of the previous blocks. Those hash of the previous blocks creates the chain between the blocks. So next slide, please. Here we are gonna see that how we integrated blockchain technology in public healthcare. So, like a secure payment procedure, a blockchain application has a life cycle that includes 4 domains, which are application domain, data domain, network domain, and device domain of public healthcare. So, next slide, sir. So here, the pharmaceutical supply chain follows several steps, as you can see in this slide. For the first table, starting from the purchasing raw material to packaging the medicine, total steps are in real-time monitoring using the blockchain. So here are the different steps from the for the medicine and other medical equipments, and also as well as healthcare service access by the patients. So these are categorized in 3 part: in the field, in transit, and within the network. So next slide, please. So, as we know that blockchain technology has already implemented in worldwide, and here are the international research works like defining secure and efficient exchange of health data, collaborating with FDA USA, and the facilitate the secure sharing of information among the FDA. So these are the international implementation. So next slide, please, sir. And here are some medical schemes provided by the government of India, but there are also some limitations on accessing the data, the transparency of the data, and also benefits of public. So next slide. So coming to the key solution for those limitation, we provide unique healthcare ID secure database for each identified family health information and medical tracking. Here you can see the blockchain network where the patient can generate healthcare IDs and share those their prescription or reports, or pay the bill. So these all are connected in interconnected in blockchain network, so of public healthcare. So next slide, please, sir. So our model has proposed that we have the solution for those limitation. As we discussed before, we will provide a app or a website where a patient can generate unique healthcare ID number and share the document of their prescription or previous health issues reports. So they can pay the bill also through the card using this unique ID number. Patient or a patient family can collect or share prescription bill payments from any government or private hospital or pharmacy. Similarly, a patient can consult online with the doctors. As you can see, we are providing emergency service also. The auditor will track the record of medicine reports to avoid fraud drug cases or fraud reports, anything like that. And the
Asmita,
developers
2 more minutes.
Okay, sir. The developers will also maintain transparent and secure transaction with the user through the cloud server. And so next slide, please. As we are serving a healthcare system, so we will very responsible to provide the fast and secure service with limited cost and privacy of health information, and decentralized audit for pharmaceutical drug chain. So next slide, please, sir. So while working on this model, we have faced some challenges such as massive amount of data storage or consume. So there will limited costing of implementation, and also the another two challenges are public-private collaboration and multi-level training and learning about the system. So next slide, sir. So these are the references from where we have collected the data and related research works for our work. So that's all, sir. Thank you.
Excellent, Bipasha and Asmita. So panelists, any question from your side?
Yeah, so this is Professor Amlan, Ashmita. So I have a question that you are proposing a framework, okay, which can which is enabled by blockchain for healthcare services.
Yes.
Now, compared to the standard blockchain services, right? Are you focusing on any particular aspect, okay, specific to the domain of your blockchain application? Suppose for healthcare, okay. So are you trying to focus on any novelty what you want to bring in this framework?
Sir, we just want to make it more secure and just focusing on the topic that there is a certain.
What I want to tell that there are certain regulations, right? Regulatory authorities. When you go into the healthcare, right, the difference between a normal transaction in the process where maybe a service maybe a provider and consumer is transacting, right? When you go into the healthcare domain, there are some regulators also comes into the play, right? So are you incorporating those in your platform?
Sir, we just want to incorporate the transparency secure transaction using the blockchain.
Yeah, when I'm telling a transaction, see, when a particular patient is going through the health record, the health record goes both to the medical both to the medical consultant of the patient, and also goes to the insurance agent, right? And nowadays insurance agents may be multiple. So now the importance of blockchain in this domain is a bit different, because now you have to actually have an access, okay, of the records, by not only between the owner of the record and the verifier, but there are also some other third parties, right, which will also want to access the verified records, right, and also have to have an authenticated record, so that based on that they can also add up it to their value chain. So are you considering this in the context of your model? Otherwise, what will happen, that means your model will be very good, but your model will not be implementable, because when you try to implement the model, people will ask that, hey, there is no insurance there in the model. The insurance cannot get into your model. Okay,
yes,
so
sir. Yes, sir. In this case, we have to collaborate various kind of insurance companies or other medical health sector.
And secondly, you have various layers of administration. When you take the data from the patient to Samen, right? There are various layers of your administration, right? Both in terms of true medical administration, okay, as well as in terms of administration in a hospital setup. So those things are not very well framed up in the present model. It's a very generic. But what I will suggest you is that you try to go through some of the very specific use cases in this domain, transactions which happens in terms of medical records. Okay, who are the parties who handle the transactions, and based on that you can try to find that what novelty you can add up in your model. Okay, that's all from my side.
Okay,
thanks,
sir.
Dr. Chakravarti, and thanks, Bipasha. We will take this conversation next time. You can have Dr. Amlan Chakravarti over email and can discuss it. So moving on to the next one, I'm sorry for doing this, but we'll have to be mindful of the time. Next one is Gateway of Blockchain IoT meets Edge Computing Paradigm. This is again by Kaustav Kumar Mandal and Dr. Deep Subra Guha Roy. So over to you guys.
Good evening, sir. My name is Kaustav Kumar Mandal, doing MTech in IIT, specialization with IoT at Maulana Abul Kalam Azad University of Technology, which is formerly known as WBT, under guidance of Dr. Deep Shubro Guho Roy, University of Tartu, Estonia, Europe. Today, I'm discussing about the gateway of blockchain IoT meets edge computing paradigm. Next slide, please. Next slide, please. Yeah. In my presentation today, I discuss about the introduction, background of IoT, and trusted authentication based on blockchain IoT architecture, blockchain hierarchical architecture, overall system architecture, authentication process, average delay with different cache capacity of nodes, average delay with different size of contents, key challenges to implement, conclusion, and references. Next slide, please. Yeah. As the
Sorry to interrupt. This is Obijan here. So, a generic comment. Rather than describing the fundamentals, I would request everybody to go straight to their contributions and the technical thing. Otherwise, we have a lot of questions, but because of constraint of time, we are not able to, ask. So that will be the request. So you can quickly go through the introductory slides, because most of the people in the panel, they
okay,
are
sir.
aware of the basic technologies.
Okay.
Okay, thank you.
So, as the great prevalence of various Internet of Things terminals, how to solve the problem of isolated information among different IoT platforms attracts attention from both academia and also from the industry. It is necessary to establish a trusted access system to achieve secure and authentication and collaborative sharing. So, my contribution to this research, that I want to make a system or device which is a one type of gateway using blockchain to connected IoT devices with each other. Next slide, please. So, background of IoT, there is a the early form of IoT platform are highly isolated, incompatible, and proprietary connected island and centralized processing architecture relying on the cloud computing adapted to handle massive data flow, making difference to the manner of data processing. So there is a chance of there is a lack of data security, which is and then cloud computing improves the computational storage capability in centralized architecture, but it performs poorly in promoting edge processing and protecting data security. Next slide, please. Yeah, trusted authentication based on blockchain. So, in the existing literature of blockchain systems have achieved a variety of properties such as anonymity, decentralization, and system transparency. However, the less attention has been paid to achieve efficient authentication among different IoT platforms. Hence, my research proposal is a distributed and trusted authentication system based on blockchain and edge computing. With edge computing technology, blockchain edge nodes can offer name resolution and the edge authentication service. Meanwhile, caching strategy is designed to improve authentication efficiency further. Next slide, please. So here is overall the IoT architecture. In the normal IoT architecture, there is a mainly three layer, which is sorry. In the IoT architecture, there is three layer, which is network layer, physical layer, and application layer. In physical
Can you
layer,
please go to your contribution part? These
okay,
are
sir.
all well known.
Okay,
As
sir.
Vivian also mentioned, you have to go to contribution part.
Okay, sir. So next slide, please. So here's the blockchain hierarchical architecture. Is a three-layer architecture is proposed to handle trust and efficiency problems. The architecture normally consists of physical network layer, blockchain edge layer, and blockchain network layer. The set of terminals is denoted by V equal to set of V1, V2 up to VM, and set of cache nodes and resolution nodes are denoted as BC is equal to VC2, VCN, and BR is equal to BR1 to BR2 respectively. And this architecture is discussed in the next slide. So next slide, please. So here is the main architecture. Where is the physical layer and blockchain edge layer and the blockchain network layer? In the physical layer, there is a IoT devices and and using the blockchain edge layer, which is connected to the physical layer using gateway service, because gateway service, and then it is connected to the blockchain network layer. Next slide, please. Here is the overall authentication process. So the smart contracts are in this, the smart contracts are created and defining the authentication mechanism and integrating different protocols of IoT platforms by the sending of transaction to the address of smart contracts resolution, and nodes can access to the smart contracts and invoke its function. Next slide, please. Here is the average delay with different cache capacity of nodes. Next slide. Here is the average delay with different size of content. Here is here is a size and delay graph. Next slide, please. Here is a major key challenges to implement, which is data security, data volume, primary implementation, or you can say platform costing. Next slide, please. And the conclusion in this work are distributed and trusted authentication system combining edge computing and blockchain was proposed to realize efficient authentication and information sharing among different IoT platforms. Next slide, please. Here is the references where I got the ideas and the other research related work. And thank you.
So before we move to the panelists for the questions, a small comment here from my side that please coordinate with Bureau of Indian Standards, LITT 29, who are working on blockchain standardization, and they are coming up with some of the blockchain related standards relevant for Indian use cases. So you may want to either contribute or get a lot of content related to smart contracts from there.
Okay, thank you, sir.
Thanks. Any other questions from other panelists?
Hello, Kostov?
If none, then
yes, sir.
Yeah.
Okay, Dr. Dev.
So what is the difference between the blockchain edge layer and blockchain network layer? You have mentioned that.
Yes, sir. In blockchain edge layer, we have a physical device which have incorporated with the blockchain gateway, and in the network layer, it is in the like what I can say, like is the blockchain edge node, which is nothing but which incorporated with domain name resolution, and it's also maintain the DNS database and cache node and resolution node, which is stored the authentication logs.
So generally in TCP/IP model there are 5 layers. So which layer it is?
It is a
Actually,
Is
sir,
it physical layer or application layer?
no, sir. It's starting from physical layer to application layer.
Yes, sir.
It's actually implemented from the direct physical node to application type. Actually, we are planning to create some application, and we are planning to do some mix and match of protocols so that it can be start from basic physical layer to application layer like a firewall.
But how the network layer is below? How it is below the network layer? That is the question.
If you consider the entire model, so in case of the connection and in case of packet framing theorem, so in that aspect, it is under the network layer. So that's why we are planning to incorporate the OSI model 7 layers together into our proposed framework. So it is not yet completely done, but we are working on it.
What is here? I just wanted to know how did you make the evaluation? So is it like the evaluations is I saw kind of incomplete. I mean, I couldn't see anything like what you mentioned. See the contributions like it is authentication, security. It's like all what you mentioned as a contributions, but I cannot map it with the results.
Actually, the thing is that we are just working with in the age perspective. What are the age-based parameters are there regard like delay and all? So we have not yet completed. This is tip of the iceberg only. So it will take some time to complete it and with the validation. The validations are not yet done, so it is in the implementation phase. So hope we will do it very fast.
Okay, thanks, Deep, for your intervention and
So sir, Anupam sir, so I want to answer one thing to Omlan sir. Sir, regarding the last presentation, I want to mention something that I have discussed with Sanjoy Das sir regarding the administrative part, Joint Secretary, West Bengal Government IT Cell, and I have discussed with United India Assurance officers regarding that. I have done 2 meetings over Zoom. So we will sit together to formalize that task. So probably
otherwise it will not be complete if you
yes, yes sir. So we have already discussed with Sanjay sir, and we have discussed with 3 officers of United India Assurance company. So we will join very soon so that we can share the data with the authorization of the admins like that.
Good, that's good. Yeah.
Okay,
thank you sir.
Just a note for Anurina. I think there is a question in the chat which is related to your presentation, Anurina. You may want to answer that. Then we move to and thanks Deep for intervention and Kaustav for your presentation. We move to the next presentation, which is by Anvesha Mukherjee. It is on a delay aware green Internet of Health Things paradigm under edge computing.
Yeah.
So Anvesha,
Yes,
over to you.
Yeah. Please share the screen. Or I will share the screen.
Anand, you can give the rights to Anvesha, please.
Given
Or you can share also. You can share also.
Anvesha, you decide. You want to share or you want Anand to share?
He also can share.
Okay, Anand, you go ahead and share the screen.
Okay.
Yes, yeah. Good evening, everybody. Today I am here, myself, Dr. Anvesha Mukherjee, currently working as an assistant professor in the Department of Computer Science, Mohishadan Raj College. ECIOHT. EC stands for Edge Computing and IOHT stands for Internet of Health Things. A delay-aware green Internet of Health Things paradigm using edge computing. Kindly move to the next slide.
Dr. Amlan, you may want to mute yourself.
So first of all, what are the objectives of the proposed work? Now here we wish to provide a preliminary health monitoring for individual and notify him or her in case of abnormal health condition. One thing I want to mention here, in such a pandemic situation, or if I consider what the case of the senior citizens, then the continuous health monitoring or the home health monitoring is very, very important. So for those kind of people, this preliminary health checking is always important because prevention is always better than cure. To alert previously before going to the most severe cases. So our objective is to provide recommendations regarding the nearby health center also in case of abnormal health condition, to provide faster health service provisioning and reduce the energy consumption of the AIM healthcare framework. Kindly move to the next slide. Yeah. So Internet of Health Things or IOHT refers to the transmission and processing of the data to monitor the health condition of individuals. For details about the Internet of Health Things, you can go through our previous works. So as the time is very limited, so I am directly going to edge computing based Internet of Health Things, that is ECIOHT. That is the health monitoring framework we have proposed for the health service provisioning at lower energy consumption and lower delay. The main components of this healthcare framework is the body area network, that is BAN, which is composed of the sensor nodes which are attached to the human body to collect the health parameter data. Suppose blood pressure data, systolic, diastolic, body temperature data, pulse rate, etc. User's mobile device, that can be smartphone, that can be tablet, edge server or cloudlet. Here one thing I want to mention, if the user's mobile device is connected to a cellular network, then it is connected to a base station. Or if the user device is connected to a Wi-Fi access point, then the cloudlet can be used, and in case of the cellular network, edge server can be used. Here base station is currently the concept of edge computing. So the edge server is attached with the base station, so that the users can offload their computation inside the edge server also for faster service provisioning, to bring the access to the storage and the computation to the network edge. So that is the concept of edge computing. So here, if the user is connected to an Wi-Fi access point, then cloudlet can be used for health data processing. If through a cellular base station, then the edge server can be used. If the user is connected to an indoor base station, like small cell cloud enhanced node B, femtocell, if it has the processing and storage ability, then health data processing can also takes place inside that one. And finally, cloud server. Please move to the next slide. So this is the basic framework. Here the body area network, here we are not only considering the health data, but also the contextual data is very, very important, because what is the user's health profile if he or she has some medical record. Suppose myself, I am a patient of thyroid. So my actually heart rate is quite higher than in case of the normal people. I have some other medical issues also. So profession, for example, athlete, or what is the ambience temperature, what is the ambience humidity, what is the ambience pressure, and user's geolocation information, that is also very, very important, so that the contextual data as well as the health data collection takes place, and the accumulation takes place inside the user's mobile device, and from the mobile device it is transmitted to the edge server or cloudlet, and edge server or cloudlet, the health data processing takes place. And if in case it is an abnormality is detected in any of the health parameter data, then the user is notified through an alert message, and the data is transmitted to the cloud server based on the user's permission. And in case of abnormal health condition, that as the user's geolocation information is also collected, the nearby health center is suggested. If the user is a moving user, then optimal path to the nearby health center can also be suggested. Here one thing I want to mention, for the in one of our previous work, MOBI IOST, based on the user movement and trajectory analysis, optimal path prediction to the destination of the user, we have proposed a method. Users can, you can for details you can go through that paper. Kindly move to the next slide. Please move to the next slide. Yeah, here I have discussed the step-by-step process. So next slide, please. If the collected health data, now how we are actually here, again I am telling, we are just performing a preliminary health checkup. Okay, so what we are doing, we are considering the health parameter data set. So if we have and for each
Anvesha, we are not able to hear you. Anvesha. Anvesha, we are not able to hear you. I think we have lost Anvesha, so
Yes.
So we will wait for So we'll move to the next presentation, and then we'll come back because she has got another 5 minutes left. So we'll give her that time. So can we move to the next one, which is Medical WSN Energy and Security Challenges by Dr. R. Vidya.
How for network problem I got disconnected. Kindly
Oh,
share the
okay.
slide,
Thanks,
please.
Anisha.
I got disconnected actually due to some net. Actually, I am currently residing in a remote area, so that's why maybe some
No, that's
connection
okay,
problem is
Anisha.
happening.
That's okay,
Kindly,
Anisha. So, Anand, please share
share.
the slide quickly.
Um, Yeah, so actually for each health parameter, we are checking that one. So if any for any of the health parameter, any abnormality is detected, then an alert message is sent to the user's mobile device. So first of all, we have done a simulation in Walnet for network simulation part, where we have determined the average delay and the energy consumption in case of this framework. So compare the result with only cloud only healthcare framework. For the number of items transmitted within the consecutive nodes is considered 100, each having 256 to 120 bytes, and simulation time we have considered 600 seconds. And this is the sensor nodes. Here we have considered sync node also. Here one thing I want to mention, nowadays the mobile device can also actually the data for experimental purpose, we have directly actually used the mobile device where the data collection and accumulation takes place. So it is observed that using the proposed framework, we are reducing the delay as well as energy consumption than the energy consumption than the cloud only framework. Kindly move to the next slide. Please move to the next slide. Yeah. We have done experimental analysis also. Here, Fitbit we have used, and other pressure measuring module we have used, blood pressure measuring module. So here, please move to the previous one, experimental slide. Experimental analysis slide. Yeah. So actually the health data collection as well as the we have considered the ambience, humidity, temperature and pressure data and user self profile all are in CSV files we have considered, and that is transmitted to the Raspberry Pi. Here we have used as an edge device, and Amazon EC2 instances we have used actually for the cloud service provisioning. And we have collected the pulse rate and blood pressure data, systolic and diastolic blood pressure data for 1 week for 20 volunteers. One of them has been given here, one of the data. And based on the volunteers data, we have observed that within the age limit 20 to 29, 30 to 39, 40 to 49, that 4, 5, and 7 are suffering from pre-hypertension. So we have done a preliminary implementation of the proposed framework. Please move to the next one. Next slide. Yeah, so actually we have proposed a preliminary health monitoring framework based on edge computing. Based on the simulation results, we have observed that we are reducing the average delay as well as energy consumption than the cloud only healthcare framework. And the experimental analysis, we have done a preliminary experimental analysis we have done. And in future, we are not only considering the ambience data, user self profile, and we are considering the activity data also. That is also very, very important, because what the activities, previous set of activities the user has gone through. So that is also very important. And mobility based health monitoring. So those we are currently working on that. I wish to acknowledge in that case Professor Devashish Te from Macau WB, Professor Shomokanti Ghosh from IIT Kharagpur, and MS Shreya Ghosh for their immense support during the experimental analysis. So thank you.
Thanks, Anvisha. Any question by the panelists?
Yeah. So yeah. So
No, Amar, sorry,
Anisha,
please go ahead.
yeah.
Yes,
So
sir.
Anisha, that means I am fine with the network or with the energy optimization what you are doing. I think okay, it is good. But I have one one suggestion, or okay, one understanding what I want to convey you is that when
Yes,
you try
sir.
to work with health data in real time, right? It is not good to transfer all the data which is being sensed, okay, for a particular patient, because that means further exploits the battery of the sensor. So now the technology is moving where we call the event-based detection. So we do a short window-based temporal analysis of the data, and we only pass some of the events, okay, which are different from the normal. So that actually, okay, it may be outlier events, right, which may be events which are over a threshold, okay, so that this helps to preserve the energy, okay, and also to limit the bandwidth, and also when you have a continuous pouring of the data, it is a in respect to security also, it is a constant activity, okay. Yeah, so
Sir, one thing I wish to mention, actually my connection got
yeah, so
yes, sir. Actually, in the framework also only the abnormal data, only that is synced to the cloud. Otherwise, if the data seems to be normal, then the data transmission to the cloud will not occur.
Then you have to show that what is the temporal analysis you are doing. Okay, what is the time series analysis you are doing. Okay, or you are doing a sort of network flow analysis. Okay, where the dynamic network changes with time, and whenever the change is an abrupt, then you report. So that reporting mechanism, okay, should be very strong in this type of health data analysis.
Yes,
okay,
sir,
that's
yes,
fine
yes,
from my side. Yeah, I am fine.
Thank you very much, sir, for your suggestion. We will certainly go through that. Thank you, sir.
I have some comments to make over here, and these are generic comments, and that may be, that may be across many of the researchers who are presenting here, and also part of the bigger community. So, considering the current trend in technology, one thing that I would suggest that maybe when you're thinking of any research, considering an edge, like in this presentation also we heard about different forms of edge, and how an edge can be part of a network infrastructure, and there are different manifestations of edge depending on where the edge resides. So 5G technology is coming up considering edge as an integral component of the whole network stack. So I would request researchers to take that into account. So whatever they will be doing, that will be readily plug and play with the upcoming network topology that will pervade the society. The other thing is, and this is also a horizontal comment, which is that whenever you are talking about uploading data from sensor, I mean, this applies to the person who was working on the music things as well. There can be also a significant amount of thought process being put in the semantics of how this data is being represented. Okay, because while there is computation and all these things that people are mentioning, but it is a common thing that a bulk of the energy is wasted or is spent in transmission. It is the you can consider that the 50% of the energy or whatever you will do in a distributed system, communication is the main thing, and that energy is directly proportional to the amount of number crunching the different layers of communication stack has to do. So the minimization of the data, I mean, minimization of the information that you want to put. I mean, if you took example from ITF, there are plenty of standard, recommendations in how you should represent data. Like for IoT, there is people are talking about CBORD. Then there is, shorter versions of XML and all these things. So that is something that you need to think so that it can be readily applicable to an industrial usage and a practical usage. So these are two generic comments.
Okay, sir. I will keep in mind.
Thanks, Abhijan, for your comments, and thanks, Anvesha, for your presentation. We move to the last presentation in this forum, which is on energy and security challenges in medical WSN. It is by Dr. R. Nidhya. He is from Department of Computer Science and Engineering, School of Computers, Madanpalli. So, Dr. Nidya, over to you.
Good evening, sir. Good evening to one and all. Sir, shall I share my screen?
Yes, please. Go ahead and do it.
Thank you, sir. Okay. So here it comes. It's about an overall picture of what we are going to discuss now in this particular presentation. Actually, it started with that basic one is nothing but wireless sensor network. Everyone knows about wireless sensor network. It is a tiny device which can gather the data from a certain place, which can be transferred to a remote place so that through a wireless communication, right? This is a normal definition, so we don't want to spend time here. In WSN, we are having a multiple number of applications. In that, the most important thing we are going to discuss here is the health monitoring. So the wireless sensor application related to the medical field is known as the medical WSN. If you are seeing about medical WSN, the overall architecture is divided into three basic types. The first one is a sensor node, which will be in a person's side. Then another one is whatever the data captured from the person or in a place, it will be transferred through over internet or some kind of technology that can be anything that will be transferred from the observed place to the another remote place. That is a tier 2 of architecture. The tier 3 is the place where we are going to save the data so that wherever we are, we can easily access the data. So the main purpose of this one is the patient can be anywhere, but without face-to-face communication, we can treat the patient in a better way. So this is a basic thing. If you are taking this particular WSN, we are facing many challenges are there. But if you see close to that, the basic challenges are the security, reliability, and energy consumption. Let us comes to the security, because everything is a health-related data. We are going to transmit the data in a wireless medium of communication. So we don't know what the things will happen while the data is in transmission. So that is, suppose something miscommunication has been happened, it is a life-threatening issue of the patient. So we should provide more importance to the security part. This is the first one. So second one, reliability of the data should be there. Then only we can give any kind of treatment to the patient, and we can rely the whatever the treatment we are getting from the doctor side. So this is also one of the basic QQOS of the WML. Okay. The last one is the energy consumption. Why? Because it is a sensor based thing. Suppose that particular data is not reached at the sender side. So again, the data has to be retransmitted again and again and again. So what will happen? This will consume more energy. And if suppose whatever the route established for the sender to receiver transmission path, suppose the route is keep on changing in dynamic way. Suppose there is a unreliable data transmission or something, multimedia data is transmitted in that path. So all those things will consume more energy, which will make our entire system to drain so. So these are the basic problem that we have observed. So I'm going to propose a certain kind of one of the solution for overcoming this particular thing. So these are all the some of the related field study that we have done related to this field. So what is the overall picture of all those literature papers telling, like energy and energy consumption and security are the most important challenging factor in a medical WSN. Okay, so the thing we came to know, one is the unreliable data transmission, which is nothing but security. Next one is the energy consumption. So what we are going to do is we are going to propose one kind of proposed method, multi-tier security architecture with energy requirement medical wireless sensor network. Okay, the main motto of this particular proposed method is to reduce the data loss. How we can reduce the data loss is we are proposing that entire architecture in a two different basic components. One is the security model, another one is the energy efficient. Let us come to the security model. So here the multi-tier security architecture has been proposed for this particular method. So what is meant by this multi-tier security architecture? This is our proposed model. We are having a healthcare authority. The data will be stored in a cloud server. Here is the caregivers are there. Here is the patient side. Okay, the patient side is having a sensor controller gateway, and it is having some energy monitoring unit. Everything will be in the patient side. The caregiver can see all the details of the patient side somewhere else. He is at remote place, but he can monitor the patient in a time to time basis. There is no need to doing a physical verification. So here what we are doing is how we are providing multi-tier security architecture is we are providing a two-tier of, it's not a two-tier, the basic security is provided in two layers. The first one is the end-to-end encryption, which means that patient to doctor, we are going to encrypt the data in a totally in a first layer of encryption way. So second thing what we are going to do is wherever the data is moving in between, wherever the accessing point is there in between, each and every place the data will get encrypted. Again, it will be encrypted so that even though someone is intruding here, they are getting the information, they couldn't get the entire information. They can decrypt only this part, still they don't have the caregiver information details, so that say they can't do. So how we are doing all those things is we are using a elliptic curve cryptography method here. In addition to that, we are going to do a distributed way of data sharing here. So what we are doing here is we are using a bilinear mapping concept to generate a group key here. Okay, so properties are there to satisfy to generate a group key for the entire transaction of a single user patient. I mean, okay, that kind of thing is happening over there. So the entire process is happening using a elliptic curve cryptography process. So what will happen whenever the data is transmitting here, the sender's private key will be encrypted with the receiver's public key. So like that, data will be encrypted. Again, the data will receive at receiver side. The receiver can decrypt the data using their private key. Like that, it will be encrypting and decrypting process is happening defaultly. So it is not only happening at end to end, wherever the data is moving in between each and every place, this entire process is keep on doing, so that it is providing a not a single layer of security, we are providing a multi-layer of security we are providing. So this is the way how we are protecting, how we are giving a protection to our data while in transmission. So the next concern is about energy efficient metric, right? So usually how the data will be transmitted from one part to another part is they use it to always count the number of intermediate nodes and the distance between the devices. Like that, we may add another 2-3 parameters, maybe energy availability, like that 2-3 parameters they may consider. Here we have considered the 6 different parameters to establish a energy efficient routing path. Okay, what are the things we are considering? First thing, how many number of intermediate nodes are there? Then what is the link reliability? What is the consistency of the established link? How many already I have sent a certain number of packets through that particular link. How many are successful? How many are not successful? That I have to take care. Then what is the energy availability? Is nothing but how much energy is still available in this particular network to continue the process in a better way. Then what is the buffer size? How many number of packets already in queue? How many are yet to can accommodate in that particular path? What is the bandwidth, allocated bandwidth is still remaining in that particular path? Everything are considered into a then only the route will be established between the sender and the receiver part. So that what will happen now, because of considering all those 6 factors together, there is a possibility of reducing a retransmission of packet. When the retransmission of packet will happen, when the packet is not reached at the receiver end, again it will ask for the packet to transmit once again. It will again re-scenarios that packet loss may happen. So to avoid these kind of problems, we are using this kind of, before starting the established through data transferring, we are make sure really that particular path is reliable to send a data or not. This is we are making sure, then only we are start transmitting the data. So by considering those two proposing a certain thing which is giving an energy efficient path, at the same time secure path as well. So how we are evaluating our proposed method? No? We have taken many metrics here. Why? Because it should be evaluated at all the dimensions, because we are considering security as well as the energy at the same time. So that 12 different parameters has been considered here. How much energy is consumed, how much remaining energy is there at the end of all the transmission has been done, how much packet has been delivered at the end of the transmission, what is the normalized rows, I mean how many control packets has been added while I'm transferring the data packets, what is the throughput, what is the good put, what is the delay, what is the dropping ratio that I have found in throughout my data transmission, then what is the relative energy still existing in my network, then what is the lifetime of my entire network, then what is the jitter value, right? By considering all these parameters, I make sure really my proposed method is working fine or not. Okay, this particular method is analyzed in three various scenarios actually: linearity, scalability, congestion control. How these three scenarios has been established, all these things we have simulated in NS2. So this is these are the things simulated by increasing the number of nodes, by increasing that time duration of the things, by increasing the number of packets per second. Like that, we have given a three different scenarios to check how under
Dr. Nitya, we are not able to hear you.
that one, the proposed work is clearly working better than the previous one. Scam is nothing but one of the proposed method. Like they have used the ciphertext attribute based encryption kind of technique they have used in that particular method. It is end-to-end encryption. So while comparing to that particular method, that proposed method is working fine as per all the different types of metrics because of
Dr. Nitya, we are not able to hear you. Dr. Nitya, are you still there? We are not able to hear you. Dr. Nitya? Dr. Nitya?
I think there is some problem in her connections. He left the meeting.
I can't see
Yes,
her
yes,
mic
yes.
as well.
Yes, yes, yes.
Sorry. Hello.
Yeah,
Hello.
again. She's back.
Sorry,
Okay.
sir. I don't know where I got disconnected.
Okay, please go ahead.
I'm sorry where I got disconnected. Still, actually, I went till reference part.
So, Anand, can you put the slides back on?
Yeah, I think it was the result slide.
So it is under my control, sir. That's the problem. I gone through all the slides. I went to the end. Actually, I came to the references.
Okay, so
There were
you
some
were just
results.
before the references, you were talking about the results and also we lost you there. So it is absolutely fine, Dr. Nitya. So Abhijan, Dr. Manohar, maybe any one of you has any questions for Dr. Nitya?
1 second, Anupam. She was in results and discussions linearity.
Sorry, sir.
Yeah, that is okay. So,
Okay.
So anyone has
So
any
shall I start
questions?
from results and discussion?
No,
No,
that is
I
okay,
think
Dr. Nitya.
I think
We are good.
got the essence of the work, but one thing is not clear. Like whatever issues you have spoken about, they are some standard. There are standard mechanisms of doing those things in real world, and there are standardized protocols. For example, end-to-end security is there. I mean, there is TLS 1.3 and many other protocols, like Quick is doing end-to-end security. Then congestion control is an age-old problem since the inception of internet, since the inception of TCP/IP and its implementation. What is not clear is, you have touched the right issues, but what exactly you have done and what was the contribution and where is it leading us to your work?
It's about algorithm what we have applied for security, sir. Actually, the end-to-end encryption is all, yeah, everyone are doing that. But what we have done is the sender to receiver encryption. We are doing, right. But what we are doing is we are doing another one kind of already the data is going to be encrypted from sender to receiver. Meanwhile, whatever the first one, I will encrypt my data as per that shared key between sender and receiver. Now I have a encrypted data. Now I have to transmit this encrypted data from sender side to receiver side. But before doing transmitting that data, what I'm doing, I'm having so many accessing point in between, because it has to reach my access point, and it has to reach the hospital server, and again it's going at somewhere else. So many points are there in between. So what we are doing is, our encrypted data, before it's going to reach the other point, again we are doing a one more encryption. So encrypted data is again going for another one encryption. For that purpose only we are using a group key. So that what is happening it is we are having a certain kind of public key and private keys assigned to each and every device available in between. So we know how it is happening, that sharing of public key with the secret key of this sender and receiver. It is creating a secret key at each and every level. So encrypted data again encrypted, then only its travel from the sender point. Again I am reaching the point. There also.
Okay, Dr. Nidya, thanks for your response. So, but we are seriously out of
Again I'm
time here.
getting the. Sir?
Dr. Nidya, thanks for your response. So, but we are seriously out of time here. So, thanks once again for your work and your presentation, and thanks Vijan for your contribution and comments. So, we reach to the end of our PhD forum with all the presentations. Now, straightforward, we have eaten up the time for the break. Now we'll go straight into the next part where we will learn from the learned speakers. So we have uh, Suresh Krishnan among us. He is one of the specialists in the ITF area. He is currently the CTO of Kallum, where his main work area are in the work area of data center networking, software-defined networks, 5G, and machine-to-machine communications. So, Suresh, welcome to this forum of India Internet Foundation, and we are really glad that you could join us today, and we are very thankful that you could give us some time. Here, what you are seeing is a community of young and budding engineers from India who are trying to work in the area of internet, and they have presented in last 2 hours some of their works. And we do have some great panelists among us, starting from Mohit, Abhijan, Dr. Manohar, Rishabh, Professor Amlan Chakrabarti from Calcutta University, and we have Dr. Devasis Dev from Makaut, which is again one of the biggest universities in the state of West Bengal. And they have shared their comments. There has been a lot of takeaways, and now we are here to hear from you that what 5G is going to do for us, and your especially the area of your work is very relevant for India. So Suresh, over to you, and thanks once again for joining us.
Yeah, thanks, Anupam, and thanks, Abhijan, like for this invite. And I'm really excited to speak to this group. And yeah, like I was this young student once too, so like really interesting stuff happening here. And always like feel free to ask questions, and like we can like clarify at the end as well. I'll try to keep my presentation short, so we can have like a little bit of time for discussion at the end. And just to like talk about like really specifically about what I want to talk about, like it's like not just 5G but at the edge as well. So there's like these two things. Actually, there's like multiple technology trends that are converging these days. Like 5G is one, the move to the edge is another. Also, again, move from bare metal to VMs to containers is another. So it's like a really exciting time, specifically in the mobile networks, as well as like the networking industry. So I'll just like start off, and then we can go from there.
Suresh, are you going to share some slide?
Yeah, it's coming.
Share. Yeah. Okay.
You see it?
Yes, we do see it.
Okay, short introduction from me. I've been in this industry 25 years. Like I started in mid '96, so long time in the industry. I worked for I started off working for HCL Cisco, and then at Cisco and at Ericsson, close to 2 decades, and now I'm the CTO of a startup, and we are doing work specifically in this area, and specifically with 5G and edge and programmable networking and so on. And yeah, I've done quite a bit of work at the IETF. Most recently, I was the internet area director at the IETF. I had my 2 terms just finishing up mid of this year. So I know Abhijan and Mohit from there. And so I have about 30 plus RFCs and quite a few patents. So and I actually did work in a research group when I was at Ericsson. So I did have quite a few PhD students and master students I worked with as well. So I am really excited to see quite a bit of innovation happening in India. And so just starting off with the basic changes in 5G, right? So 5G is the newest generation of mobile network technologies, and this is not new, right? If you look at what 3GPP does, like clockwork, they come up with newer generation of mobile technologies all the time. So we started off with the first real one with data was GPRS, then we had 3G, then we had 4G LTE, LTE Advanced, and so on, and currently we are at 5G. And so 5G is kind of a combination of multiple things. So when people talk about 5G, there's a radio piece and also a network architecture piece. So they're both very important. So the radio itself is the important pieces of the radio itself is that it uses multiple frequencies to achieve high throughput. So there's different frequency bands over which the 5G radio can run. So it can run in lower frequency bands, it can run in mid frequency bands, and in really, really high frequency bands as well. So this gives a lot of flexibility for people to deploy 5G, but it also has some downsides. So the larger amount of spectrum, the more bandwidth you need, you really need to go into the higher spectrum, which is called millimeter wave spectrum. And if you go there, the range is pretty small. So just to give you an indication of how small, in a lot of the cases to get your maximum throughput, you need to be a few hundred meters from the base station. So that doesn't give you a lot of room to put this everywhere in a country like India, right? And so the idea is you use this to build capacity in urban areas, but also use the lower frequencies to build coverage in larger areas like rural areas, like suburban areas, and so on. It's something you need to do. And the throughput is extremely high. We have seen a lot of demonstrations and actual in real networks of gigabits per second throughput, over a wireless link. And so this is something that's a game changer. So when I was in India, right, getting a little bit more than DSL speeds was very, very difficult. I remember the times when he had this modems and with this beeping tones and everything, and we would barely get 9600 bips from VSNL. So things have changed quite a bit, but still the economics of doing a fixed line to somebody's home haven't changed. So it's still very expensive to get a cable to everybody's place. So this is going to enable something that's called fixed wireless access. So if you have a lot of throughput, you could have a beamforming antenna pointed to a bunch of people's houses and get really high throughputs without laying the cable. So what you're trying to do is not only become a new generation of mobile technologies, but also for connecting homes as well. So that's going to be possible with 5G. It's always been possible, but it's with the technologies that are in 5G, it becomes much easier and possible to provide much higher throughputs. And the other key feature, this is not talked about much, but I think it's equally important, if not more important than the throughput, is the amount of latency. So we are really trying to cut down the latency, both on the radio side and the network side, to something really, really small. So there's a lot of applications that have very low latency budget, less than 5 millisecond round trip, pretty much, from something happening to some reaction needing to happen. And these things are going to be enabled by 5G. So because the radio latency is very low and the network latency is also going to be low, but it also places some constraints on how you build the networks, and that's kind of the main scope of my talk. And as I said before, a lot of frequencies, the high frequencies are going to have a much smaller coverage area. So this has to change how the networks are getting built. So like I would like to use this slide. Like this, the CEO of Verizon, he used to be the CEO of Ericsson before, and he did a presentation last year at CES, right? Like when we had like still had conferences like in real life, and he talked about a few things that are like important in 5G. So like of course the data rates are like pretty high, and like this is like people are talking about up to 10 gig per second, but like gig per second is going to be pretty common. And the data volume, like how much data volume you're going to have. So imagine in a square kilometer of area, you're going to have 10 terabit per second of throughput. Like this is something unheard of, right? Like this is not going to happen this year or next year, but 5G is like here for probably another at least 5-6 years minimum, and that's where things are going to be trending towards. And support mobility. So so if you look at like stuff like the bullet train in Japan and so on, like there's like a lot of high-speed trains coming in India too. The idea is like the mobility is going to become a key factor. So like the cars are going faster, the trains are going faster. The idea is like we still be able to provide connectivity to these things. And the other piece, like this is like kind of really more in Mohit's territory, really, right? Like there's going to be like a whole bunch of IoT devices that are getting connected to, right? Like there's like 1 million devices per square kilometer is like going to be common. And energy efficiency. So like if we go down the same path, like if you're going to have the same watts per gig per second for doing like the stuff for 5G, like we're gonna not be very, very green. So we're gonna cause like a lot more pollution and like consume a lot more power, resource exhaustion, and so on. So we need to be like way more efficient processing the data as compared to currently. And we need to be able to deploy services very, very quickly, because like things are getting like hyper local. Like we need to be able to go and deploy and undeploy services very, very quickly. Like doing stuff like in a matter of months or years is not going to be enough. And reliability needs to be very high, and end-to-end latency, like the goal is 5 milliseconds, and this includes the application itself. So one of the things, like this is like from like Red Hat, like which is like a company which is like heavily invested in the edge and telco over the past years, right? And Paul Cormier, like who I know pretty well, he said like 5G is changing the world, but the edge is changing 5G. So this is like a very, very interesting perspective. So like everybody is talking about 5G and how it's changing the world, right? But the edge is also something that's happening at the same time. So like people are trying to change the deployment architectures from everything being centralized. So if you look at the last 10 years, things have gone from everything being very, very distributed to everything being very centralized. Like most people use like Gmail, like for like all the mails, like people use like Netflix and so on. And that's kind of like there's like a trend of like centralizing everything. And like people go to Google Cloud, AWS for deploying all the applications. So things have become like kind of like everything moving towards like a more centralized network. And this is really like kind of driven by like the cost, really. So if you look at like cost of like building your own data center and running it, it becomes pretty expensive, like compared to like kind of outsourcing the whole thing, especially if your main business is not networking, right? But that's kind of that trend has to kind of reverse. Like it doesn't mean that it automatically gives you a free decentralization of the internet, right? Because like it could still be the same players, like kind of moving the stuff out, but it at least gives an option for people to do things in a slightly different way. So this is like very, very key prediction, right? It's coming from Gartner. It says like most of the data, right, that's created and processed will be outside a traditional data center. And in the next 5 years, they predict it's going to be 75% of the data. So this is like mind blowing, right? Like right now, like, all the data processing is happening, like whether you look at like connected cars, sensors, like pretty much anything you do, most of the data is getting processed in some huge data center probably in the middle of nowhere with a lot of power and cooling. But the prediction is that, and we do see this happening. So I don't know about the numbers, specifically 75%, but like there's like a lot of data moving out closer to the user because like specifically because of latency limits is one thing, but also like, transport costs from hauling all this data back to like a centralized location. So data is not going to be centralized anymore. Okay. And if you look at it, like the economy itself, right? Like if you look at like, the size of the market, in the edge, like you see these numbers, like, they're like pretty small numbers right now, right? Like, by small numbers, like a couple of 100 billion, it's not a small number. But if you look at like the growth curve of this, you're going to see like a lot more money coming in into the edge. And of course, like, like a lot of us, like at least like the group of people here, right? Like we are involved in the lower layers of this, right? Like, the hardware, the connectivity and platform. And that's like a huge market, right? But there's also like a large application and services market. And this is something that again is very important, right? Because the applications also have to be adjusted to run at the edge. So there's like a lot of platforms. If you look at like stuff like Kubernetes, right? And the idea is like, they have to provide some kind of developer tools and stuff like that, and provide like a common platform where people can write applications both for running in like some centralized location as well as do stuff on the edge. And of course, the public cloud players, they also want to play in this market. So they're coming up with like, solutions like Outpost or like, IBM Satellite or so on, like, or Anthos. Like the idea would be like, the public cloud players also want to have some kind of presence at the edge sites. So what are the kind of applications we are talking about, right? Like, so some of them have always been on the list, right? Like, they never like been a big deal for wireless networks, but like, VR and AR is like something that has like always been around. Like, they have been pretty clunky and not so easy to do. So there was this Ericsson video, if I remember, from like 10 years ago when I was working there. We made this video where you would have somebody having a VR goggles, and they, what you do is like they're playing ping pong. So this guy's like a world table tennis champion, right? So he's playing table tennis, and then you put in like 25 millisecond or 30 millisecond of delay into his like, so he's like playing really well, right, against the opponent. And then what you do is like you put in like a little bit of latency into his thing, and he doesn't even hit like one ball, right? So latency becomes like a very, very big deal in here, and 5G enables something like this to work really well. And also industrial control. So we did this demo at Open Networking and Edge Summit, like probably a couple of months ago, actually in September, where like, we worked with IBM to show like a real-time fire detection using 5G and the edge network that we built for them, right? So where like somebody would watch, like they would actually show a picture of a fire, like it doesn't make a big difference, and it will go to an inference model that's actually running somewhere like at the edge, like it's actually trained somewhere in a centralized location and download to the edge, and it can actually find out that this is actually a fire. And we also did something for mask detection. So we had like a factory where like some worker would not wear a mask, and it would immediately get flagged and warned right away, right? So those kind of things are like really possible with 5G and the lower latency. And similarly, like connected cars with like, a lot of throughput. So there's of course going to be a peer-to-peer network between the cars as well as the infrastructure in there, but there's also going to be some kind of data that's going to be collected about the car itself. So we are talking about like terabytes per month of like sometimes terabytes per day of like stuff coming from the cars if you have things like LiDAR. So, and also interactive gaming, like I think like everybody kind of plays like games on their phone. So this is becoming like something that's important and very performance sensitive as well. And also remote medicine. It's now more critical than ever that people are able to do stuff like diagnose like things and even perform treatments remotely. So you don't really want like a lot of latency when somebody's trying to cut a muscle or a nerve. So I think like these things are driving the demand for a lot of requirements like in this area, like the latency, the availability, and the performance, right? And also since all these numbers are going up and the subscriber revenues are not going up, there's like a need for like greatly reduced total cost of ownership.
মাংসটা তাহলে কে রান্না করবো? 8টা বাজতে যায় তো। এটা আগে দাঁড়ানো যাবে কি না? আগে দাঁড়ানো যাবে না। এখানেই থাক। নয়তো তুমি চলো না, আমি পরে চপ নিয়ে আসছি। কি নেবো?
People who are not speaking, can you please mute us? Yeah.
Cool.
Go ahead.
And so so another piece that has happened, right, like I talked about earlier, is like really the containers, like the move to containers from virtual machines. So like about 10 years ago, we had this move in networks from going from a lot of physical appliances that are purpose built into running stuff as like virtualized network functions, like or VNFs, right? So that was the whole NFV movement that happened in the networks. But now there's another further move, like moving into containers. And the big advantages of containers, there's like two like main reasoning like that, like, people are moving from VMs to containers. Like one of them is it's way more resource efficient to run containers. So on a computer where you can run probably 10 or 12 VMs, you could probably do like even hundreds of containers, like in the same machine, like doing the same applications. So you can pack a lot more instances of like, your application with containers than with VMs. That's one side because they're like pretty lightweight. And the other side is like, it's very easy to spin up a container than a VM. So VMs take like minutes to load, like from scratch, but a container can be spun up in like a matter of seconds, right? So this means that you can actually, if you have something at the edge where there's like not much space or power or cooling, you can like instantiate the applications pretty much at the last minute when you need it, right? Like instead of like, providing everything up front and running. And they're also very modular and scalable. So you can build stuff like, service chains or service meshes very easily with containers without using like very heavyweight mechanisms, and which is again very important for the edge. And one thing that comes up, like whenever like we talk to operators, like, hey, why don't we simply use the public cloud, right? Like, and of course, this is the way like a lot of operators are going through, right? They're saying, okay, like we'll go to like, Google Cloud or Amazon Cloud or like Microsoft, like with Azure, right? Like we go there, right? But it's not simple. Like that's really good. Like if you have a centralized data center and you want to move some applications over, that's really good. But if you have edge, like where you have locations very close to the user, so imagine like in like, like somewhere in like middle of Kolkata, like, the operator has like a cell site with some servers in there. Imagine the difference if it has to go to some AWS availability zone somewhere else, like to get processed, right? That's going to add quite a bit of latency. And I took an example of like downtown New York. So like, from downtown New York to go to a nearest public cloud instance is like 20 millisecond round trip. So if your application has like a 5 millisecond requirement, obviously this is not going to work. And the other piece is like the transport connectivity, right? Like back from the radio sites to the data center, it's pretty expensive, right? Because it actually has like, either like, laid wires or cables or lease lines or whatever. It's going to be very, very expensive. So it's easier and cheaper to run the applications locally close to the user. And so like a lot of people are trying to do this like hybrid kind of cloud approach where they're going to keep some of the functions in the centralized data centers and some of them like closer to the edge, right? So because the edge ones are obviously going to be harder to maintain, but we can talk about that as well, like, how to make it easier to maintain. But the idea is like, you need to have something in a centralized location and some things in the edge locations. And this is kind of just to show you, like, where we came, right? Like, like as early as like, 10 years ago, like we were like, still in monolithic applications with custom hardware, like big iron, right? Like people would make ASICs for the specific thing you do, give you like big boxes with a lot of cooling, and that's it. It lasts a couple of years and then it gets completely out of date and you replace it with another boxes. And then things moved like a little bit to like network appliances, but it's the same application. Like people would still put the same thing they had in these big boxes as like x86 VMs, right? Like, and pretty much like that's where we moved to. And then we slowly moved to stuff like OpenStack, where like, you could orchestrate these virtual machines in an elastic manner and I think that's how things are going to keep moving forward. And if you look at it, like specifically from the 5G network architecture, right? So one thing 3GPP did a couple of years ago is like the separation of the control and forwarding plane. So this is like something we in the internet industry have been like kind of talking about for a long time. So we had like, routing engines and forwarding cars like for a very, very long time. But in starting with like late 4G and 5G, there's something that's called CUPS that allow the separation of the control and the forwarding. So the SMF is a function that's the control function of what used to be the P gateway before, the data gateway. And the UPF is the data plane function that was like previously forwarding the packets, like the mobile packets. So now you can separate them and you can put them in different locations. So if you look at a lot of deployments, the SMF is in a more centralized location. So it's easier to manage and do the subscriber management and billing and so on. But the UPF itself, the data plane itself, is distributed like really across the network. And the big key feature is if you're going to have some kind of what is called the multi-access edge compute or mobile edge compute, MEC. The idea would be that you would be able to handle all the local traffic locally because the UPF will probably be connected to some kind of servers that are at the edge data center. So you can actually do a local breakout and handle the functions like pretty easily over there. And if there's something that's just going to the internet, you can pass it on to another user plane function that's in a centralized location that will do your standard processing. And this is like a survey we did with a company, like just to understand like, what operators want to do. And one of the important things is like a lot of the operators, right? Like 97% of like, the large operators in the world, they want to do some kind of workload execution, like really close to the edge. And by edge, I mean like somewhere where there's like up to like 20 servers like running in there, like really close to the user. And so if you think about it, like what's really special, right? Like, they're like, it's the same kind of racks, it's the same kind of like servers, the same kind of switches sitting in there. So what is really different? There's like three key differences like that, like differentiate the edge from everything else, right? One of them, it's pretty power sensitive because a lot of these edge data centers or central offices, as like people call them in like fixed line telcos, have very little power. So they're not made for large racks that consume a lot of power like today. So they were made for like equipment which use like much less power. So you have like very limited amount of power available. In a lot of cases, we're talking about like, 6 or 7 kilowatt of power. So that's probably like max of 10 servers that can be powered by this, right? And there's also significant space constraints. So this could be like a small room, locked up room somewhere. It could be like somewhere in the bottom of a cell tower. It could be like a top floor of a building where there's like an antenna. We don't know exactly where this is, but there's like always going to be some space constraints in there. And finally, there's like big latency constraints. The reason you're going out this far into the edge is to like reduce the latency. And the idea would be to really cut down the latency of everything that runs in there as well. So what do we do really to optimize the edge, right? Like the idea is like, we cannot keep doing the things the same way we are. The idea would be to like start collapsing the computer and the networking together along with storage. Like we cannot have like one different networking subsystem from one company and like, another like storage subsystem from another, which has its own networking needs. And similarly for compute, like, you cannot have like one set of switches doing 3GPP work and one set of switches doing server work, right? Like, you're trying to combine these things together to eliminate duplicate functions. Like, for example, routing becomes a function in mobile networks too. Like, you don't want to have like 3 copies of routers like sitting in your system. And also allow by deduplication, you can scale down the system small enough, like from a large data center, that like it fits into the power, space, and cooling envelope of the system at the edge. And until now, right, a lot of the computing stuff really had no idea about the network and the access and like, the different qualities of mobile. But the idea would be like you try to combine the networking pieces, like for like both the fixed line networking. So like ideally, right, you should have the same kind of hardware that's like programmable, that's able to handle like, regular Ethernet stuff, like in data centers, also be able to handle the DSL, the fiber, GPON stuff, as well as 4G and 5G, ideally in the same hardware. But because at the end, if you look at it, it's all packets, right? Like, and it has some kind of encapsulations. So if you look at regular Ethernet, it's just IP or Ethernet. If you look at mobile networks, it's like, GTP or UDP or IP, like on the same kind of probably Ethernet system. So it shouldn't be that difficult for programmable hardware to be able to integrate all these things together. And the other piece is really to reduce complexity. So imagine like, you have like 10 sites today doing this like kind of like mobile termination or like maybe 100, right? But we are talking about like, thousands of sites. Like, and so the idea would be to reduce the complexity. So there's like a lot of work here in research here. I really don't think there's been enough research done into this, like, how to simplify the operations of systems. There's been a lot of stuff, like I remember when we were in Ericsson, we did this a lot for the radio networks, like the RAN what we call self-organizing network stuff. But I don't think it has really gone further into the IP networks. There is like a bit of work done, but not really at the scale of the edge. So this is like something probably you can look at it for your research. And the idea would be to reduce costs and also provide like, the integrated orchestration for all the applications that come through. So in summary, right, like the idea would be 5G is going to bring like much higher throughput and lower latency to mobile networks. And by doing that, it's going to enable like a lot of new classes of applications that are previously unviable, right? Like, the low latency applications, the high throughput applications, and also like not to be ignored, the kind of like sensors and like also factory applications, which were not like economically feasible before. So if you had like millions of sensors, you don't want to pay like 30 like dollars equivalent, right? Like, or like, 500 rupees a month, right? Like, that you pay for your mobile phones for this. So the idea would be to really like cut down the cost as well, so that like it makes it feasible to connect like pretty much everything. So if you have like a small like, lake, like in near Kolkata somewhere, right? Like idea would be like you'll be able to measure the salinity of the lake. You should be able to see the fishing conditions and so on. All those things should be possible without putting like a very expensive price tag on it. So once you make it like cheap enough for everybody to use, things become like more valuable afterwards. And so like there was a saying we had like, back in Ericsson when we talked about this 50 billion connected devices. So anything that like benefits from being connected will be connected, but we need to make that happen as like engineers building these kind of networks. And a lot of these things are going to be possible only when we have a distributed kind of networking and computing model where things are really going out to the edge. So if you pull everything to a centralized location, this is just not going to work. So that's pretty much what I want to talk about. So I'm open for questions.
Thanks, Suresh, for a wonderful view of how 5G and edge are going to converge at some point of time. So a first question from my side before other people jump in is that there is a huge debate in India on data localization. Okay, and that is something which we are seeing being debated not only in civil society level, but also at the level of politics, where uh, the government is trying to frame some legislation around data localization. So is this the technology which we are talking, the convergence, is this convergence going to help this debate, or how do you see it unfolding?
No, absolutely, and from like I think this what like we generally call like data sovereignty, right? It's like very, very important, and it's certainly something that is driving a lot of people to keep like the data like more localized, right? It's not the only thing, but it kind of gives you like more control over where data is located. So like not only is the I would say the what I would call the political angle of this, right? But there's also economic aspects of this, which makes it very important to keep the data like where it's supposed to be stored and consumed, right? So if you have like some kind of machine learning model that you develop for some application, it makes a lot of sense to just put it like close to where it's going to get used. So like I can train my model in some centralized location, which is like subject to all these like data sovereignty laws, but I can still like push stuff out like which is like a smaller version of the model, which doesn't have the same kind of concerns, to somewhere close to where it's getting used. For example, if you're going to some other country and you need to use this, people can send a smaller version of this model to like closer to you to serve you, to give you the benefits of having the stuff hyper localized for you, but still maintaining all your data like and the model where the data sovereignty exists as well, right? So this gives you like a lot of flexibility in doing that. I think it's something that's an enabler rather than something that's going to drive it. So the laws like are the ones that are going to be driving this, but this is something that enables the laws to be implemented.
Absolutely. Okay. So any other questions from any other panelists?
Yeah. Yes, I have a question to you.
Yes, Dr.
Can you hear
Go
me?
ahead. Yeah, go ahead.
Yeah, go ahead.
Yeah, the people are talking about edge intelligence, right? So, but the edge devices are low power device. So, how it is possible to have the intelligence within these edge devices? That is my question.
Okay, so
edge intelligence.
Yeah, sounds good. So there's like as I said before, right? So I gave you an example of this, right? So sometimes, like, so if you look at like, like intelligence, right? Like AI, right? There's like two real components to it. Like one of them is to actually collect all the data, like crunch the data and form a model, right? And that's something that cannot be done at the edge. It's very clear. There's no power. It's too expensive, and there's like it's too spiky, right? It's not like really like a steady load. So those are the things you would actually take to a centralized data center. Then what you would do is you'll take the model you created with that, right? And the inference, like, then you reduce the model to a point where it can be done closer and closer to the edge. But the model is going to lose like a lot of accuracy when we going down, right? But people have done a lot of model reductions where, like, you could probably do like something with like, instead of like 95%, if you cut down to 90%, it cuts down the model like, 100-fold in size, like in complexity, right? So that's what you would do. The further out to the edge you go, it's going to be more less granular, like if I put it that way, right? Like, but it can, like, even at the devices, like if you look at, like, for example, like Google's voice assistant versus Apple's, right? So you can see like Google like does a little bit better than Siri in some of the cases. It's because like Google is sending everything to the cloud, right? So that has like its own like kind of privacy concerns and so on. But Apple is trying to push stuff to the device. So they have a like serious amount of processing, but they're not still using. My device is not using what you have done, right? It's going to use like some subset of what like everybody else in the world is doing, but it's on my device. So there's like there's like multiple angles in here. Like one of them is the transport cost, like, and the other part is the privacy, and the other one is the efficiency. So the further out to the edge you go, like your models are going to become a little bit simpler than like the ones that are in a more centralized location. They can do like much better correlations and things like that. Does it make sense?
Yes.
Yep.
Thank you.
Thanks.
Thanks. Any other question?
It says Manwar here from University. So what my question is, like, in 5G networks, as you mentioned, there's two major component or like major parts. One is RAN, another is core networks. And what is the role of like now these days, like you could say like AI and machine learning is like kind of they use kind of applications where it's not to be applied, but still people are trying to do that. But in that case, yes, like, is it what is the importance there to like make more better solutions, or like best solutions in to balance both in network core network part and as well as the RAN. And is there any already some solutions in real life, or like people are using that? Of course 5G is not there, but is there any real solution is already exist?
Yeah, sounds good. And I do have different answers for you depending on the core or the RAN, right? Like in RAN, this has been happening for a while. So one of the things, like I remember like 10 years ago, right? Like, we would do this like what is called the ward driving kind of thing, right? So what like we would do is like we'll go sit in a van with a like 3G UE or 4G UE and drive around the city, right? When I was in Montreal, like we would just like, go around the city to look at the signal strengths, right? And then like, these things will all be collected, and that will be used to automatically tune the radios like of the base stations, right? Like, the power and like, the directionality and so on. So like on the RAN side, this has existed for a while because there's like large number of base stations, and it's very difficult to manage if you had to like manually tune all these things, right? So you would just go drive around all the cities and like try to look at like the signal strands and see how to tune it. So that has existed. On the core networks, not so much, because they had like very small number of core sites. So for example, in the US, which is like a really, really big country, or Canada, right? Most people had like probably like single digit number or a small double digit number of core sites, right? So there's not been that much of a need to do the similar kind of things for the core networks. But now when the core stuff is also getting like pushed out to the edge, right? You're going to instantiate UPF functions or like very, very close to the edge. This thing needs to happen. I don't think it has happened yet. So that's like somewhere like, where I can actually study and propose solutions how to do this in a proper way. So yes, like it's happened in networks, but in specific parts of networks, mainly in the RAN.
Okay, thanks. So Suresh, we have one question in the chat that this question is from Dhritiman. He is asking that can edge should be considered as an extension of cloud, or there should be different service providers for edge?
So really good question, Dhritiman, right? Like, so, to be frank, I see both of them. Like, and it really depends on like geographies. In some countries, it's going to be more common that it's going to be the cloud providers who are doing the edge stuff as well. And in some other countries, it's probably going to be the operators. So those are the two big players in here, right? Like, there's no like major third-party players coming in. So it's either your local operator, for example, like, Geo or like, Bharti, like, or like a Vodafone Idea, like somebody might start building all these edge clouds themselves, right? Or it's going to be Google and Amazon coming in and building this edge. Like, those are the two models we see, right? And it really depends on like, first of all, how big the operator is, right? And how interested they are in technology. So some of the operators are like, kind of less interested in technology, more in operations, right? And they're going to say like, okay, like I have like this 300 edge locations here, right? And they kind of give the location to Google or Amazon to run and operate, and they kind of take space from there. So that's like one model. And the other model is they build the edge locations out, right? And potentially hand out some of these like compute power, right? Like they could give one server to Amazon to do its like stuff, or like to do some Lambda stuff in there, or they could give it to Netflix to put some virtual caches in there, right? So both the models are certainly possible. I don't think it's decided which way it's going to go. Like I think both of them are going to coexist.
So thanks, Suresh. It was a wonderful talk, and thanks for taking up.
Anupam.
Yeah.
Could I
Mohit.
quickly sneak
Yes.
in one question?
Yeah,
Sounds good, man.
Sorry.
Hi, Suresh. Good to
Hey,
see you.
Mohit.
It's
You too,
been
man.
a while.
You too, man. Yeah.
Too bad we haven't been able to meet because of COVID, but hope you are doing well. So my question was more about cycles, and I mean, we had with cloud centralization and distribution, I think the cycle is more or less following the pattern that you had mainframes, then you had peer-to-peer BitTorrent, then you had centralization, and now again we are distributing it with the edge. The same with, I guess, 3G, 4G, and 5G. But I have a feeling that the cycles are shortening. The lifetime of a 3G network was much longer than 4G. Maybe it's correct or not. But what's the reason for this shortening? Is it just like market pressure? Is it like we have actually become like more efficient and all these DevOps style, or like what's the reason for this shortening?
I think there's a couple of things, right? Like, so that one thing is like the application demands are going up quite a bit. Right? There's a lot of people that are getting connected. So this is becoming like a positive feedback loop, right? Like, so a lot of people are getting connected and a lot of applications are coming in, and mobile has really moved much faster than in the fixed line. So like, when you look at like, 3G times, right? There's like most people are still using fixed lines to do stuff, right? Like, I remember like, when I had my 3G phone, right? I got one of the first Ericsson 3G phones, right? And it was like so slow, right? Like, it's really not easy to do things with it, right? And so the ease of use of mobile, like, if you look at stuff like RuPay, for example, right? Or like, similar stuff in China, like, WeChat Pay or Alipay or something like that. Things have made like, there's people who don't leave it. Like, I remember when I was younger, I would do everything in Emacs, right? I would never leave Emacs for anything. I would do it will be my code, it'll be my browser, my email, everything would be in Emacs. So people are like used to doing stuff in mobile. So there's like a lot more need for stuff to happen. So again, like you said, it's a cycle, right? And it's shortening because there's a lot more applications that are also getting developed because of better mobile connectivity. So a lot of times I assume like I'll have mobile connectivity everywhere. And if you remember, Mohit, I don't know if like you were around at the time, but Ericsson worked on this thing called internet.org, where we'd actually go and simulate stuff in Africa. Like, for example, right, we would say like, okay, now you only have 16 kilobits per second of connectivity. How will your things look, right? So we were actually simulating things like that, right? I think Facebook was also like a signatory onto that, right? And we were doing like, lower connected stuff, and you would see the difference in experience. So I think the applications have also contributed into like the higher demands and rolling this out. I think it's not going to indefinitely shorten, but it's going to get faster at least. But this is true for everything, right? If you look at like, a vaccine today, right? Like it took like a year to come up with a vaccine instead of like 5 years, because like we have like a lot more bases to build on. So we learned a lot of new things. So it's easier to build newer generation of technology. So yes, I think it's going to shorten, but not like by the same scale like going forward.
Yeah, thanks. This is a very good example of vaccine as well.
Yeah.
So, thanks.
Yes. So before we leave you, Suresh, again a question, and this one is directly related to Mukesh Ambani. So Jio has already announced about their 5G in India. What is your views on that?
No, I think it's really, really good, right? Like, so one of the things like I saw when like 4G came out, right? Like, so forget about all the cool things that like LTE brought in, right? Like one thing, it was like it became much more cheaper for people to connect, like with the same amount of spectrum, like what we call spectral efficiency, right? It became like easier for squeezing in more data or like more calls into the same kind of spectrum. I think 5G is going to do like, it's also increasing the spectral efficiency. I think Jio is like a very important player. From nothing, they've been like, they kind of like completely uprooted the Indian market, right? Like from going from nothing to like, main player. I really think it's a good idea to do it. And I see like, similar stuff like, Yatel would also do similar things. And I think it's very, very interesting that this battle heats up. I think the one thing would be really like, where would you put these cell towers, right? Because that's like a general concern people have. Everybody wants cell coverage, except if the cell tower is on top of them, right? And
Right.
they call it in the US, they call it NIMBY, right? Not in my backyard. Like it's an acronym they use. But I think that's going to be the thing. Like with 5G, like, there's going to be like, shorter coverage areas. So it's going to be like an interesting thing how they get the cell site acquisition.
Absolutely. So that question was from Muskan Agarwal. So thanks, Muskan, for your question, and thanks, Suresh, for your talk. It was really enlightening, and thanks for answering all the questions. So we'll move ahead with the rest of our program, and please feel free to be there. You are going to see some of our initiatives in Calcutta. So thank you once again, and I bring in Anand. Anand is the founding CEO of India Internet Foundation, and he's going to talk about our initiative on iPhone Research Network. So Anand, over to you. You have approximately 15 minutes to complete it.
Yeah, thank you, Anupam.
Anand, we are not able to see your screen. Okay, it is there now.
Is there now?
Yep, go ahead.
Yeah, thank you, Suresh. It was really a very enlightening talk, and all of us, even from the beginning, there's been lots of innovation and different kind of technology talks that we have gone through in this section. So one of the initiatives that we wanted to present over here is iPhone Research Network. Kind of some activities which ISA Kolkata chapter and later on iPhone has carried forward from last 10 years, and where we are and what kind of research areas and what kind of technical works the community is involved in. It is a kind of initiative which is driven by the community. There is nothing that there is an organization which has come and it was a mandate of that organization. It is because of the community recommendations, and gradually it has come into this shape. One of the ideas of having IIW is again coming from that community approach only. So one of the initiatives that we call iPhone Research Network. It's an academic collaboration to engage engineering students and faculties in research and development projects. So whatsoever research and development projects iPhone is carrying from different perspectives, we are trying to engage students, researchers in those projects, in those areas. And this time we are there for a specific need. So one of the specific need of doing internet operations research on network layer and DNS, and it required collaborative effort for measurement data from edges and user eyeballs. So we thought of extending this research with the help of students, and there are lots of activities that we have gone so far, we have done so far. So we are approaching university campuses so that they can involve, and even faculty and students can involve over here. You can see there are lots of audiences over here from these institutes and organizations who are involved in this research. So the community, the support that we have right now is from these organizations and the universities like JS University, Kaziranga, and STPI. These are some of the organizations which are actually giving lots of effort in building this research framework. I'll just go into some sort of journey and where we are right now from where we were and how it has begun. So if we just go through our journey of bringing focus of standardization and innovation in ISO Kolkata chapter and later on in IIF, as I think we can start with 2011, and that time Anupam was ISO Kolkata chair. This is one of the pictures that you can see Vinayak over there, and an ITF awareness camp in 2011 by Internet Society India Kolkata chapter, and it was something that we have gone across what the meaning of standardization is, and how there should be some contributions on this in India, and what can be done in the future context. So we come forward in 2015, and there are 2 years that actually changed the landscape. We have been given a project from Ministry Department of Electronics and Information Technology, and we call it Indian ITF Capacity Building Program. So we have gone through lots of universities, colleges, and different organizations, and we have conducted sessions on ITF awareness, and we call it ITF awareness camps. There have been lots of papers that has been presented. It was a part of one of the websites, we call it iacb.org. And then later on, there was one ITF community meetup that has happened in Bengaluru in 2015 with the help of Nixie. And then with these all efforts, there has been some recommendations from ITF community, and you can see there are lots of efforts going on in India, and there are lots of things that are happening in different quarters, and these are some of the community members, and these are some of the community efforts that has gone into and there are lots of initiatives of shooting. So some of the key areas that we have actually penetrated, like pan-India mentoring network that we should have, like the academia would align with corporate and increase contribution from higher studies like AmTech, PhD students and faculties. And the PhD forum, you can see, is one of the aspects that coming out of this community recommendations. And more open source penetration, local mentoring is really important. So this was all that that gone through in 2015 till 2017. And in 2015, some of the community members from ISO Kolkata chapter has thought of starting a organization, India Internet Foundation. The context of forming this organization is to do something with Indian perspective, the problem statements what we have right now, and how we can solve using community collaboration. So this was in 2015 that we have started this organization. We have board members over here, me, Anupam, Abhijan over here contributing for this, and other members. Advisory board is also present in the panelists. Then in 2019, we have been awarded a project to implement advanced internet operations research in India. This was one of the projects that the idea of this project came around 2 or 3 years back. After 2017-18, we have implemented, you can say, we have hosted LRoot instance in India, in Kolkata, the first LRoot instance in Kolkata. And we were trying to examine lots of parameters of DNS resolution in different parts. And one of the key talk that Suresh has given, because of the everything is going towards edge, we were trying to understand what could be the possibility if we can do some sort of experimentation on this, involving edge networks, involving academia, involving all others, and provide a seamless research framework to all of the community members across India and world, and some indigenous solutions towards this. And we have proposed a project, and we have been awarded this. The project is funded by Ministry of Electronics and Information Technology. It is executing by STPI, and these iPhone and ISO Kolkata chapter is the organizing is the implementing agencies. There are basically three components of this project. One is the indigenous open source internet measurement framework. We have seen that there are lots of internet measurement frameworks available across the world, and every framework has its own pros and cons. We were trying to address something which is futuristic, as well as understanding the need of different other dimensions also. So we have proposed a completely new indigenous open source internet measurement framework. Second was Anycast testbed for DNS, public DNS, and DNSSEC visualization, so that we can understand what could be the possibility of having edge content networks and content distribution networks, and if it can solve the problem of DNS resolution, as well as the DNS authoritative zone publications. So we are this is one of the components of advanced internet operations research in India. And the third one is research on routing detours, DNS zone management, open source implementations. So these were some of the broad idea of having a community driven research. For that, we have started work, and around it's 1 year, more than 1 year, and lots of things has been done. So next year, from Jan onwards, we will be starting the community preview. All will be open source, so anybody can contribute in this. We are having an open source framework that we have built in. The test06.in over here, if you can ping, if you can just open this website, it is just in the process of testing. We have and maybe it can break, but again it will give you a sense that this test06.in website is located in 5 different locations in India, and it is a completely Anycast test bed. The DNS, the zone management is also done using Anycast authoritative zones. So all the DNS zone is managed by 5 DNS servers, and there are DOH and other components are also there, which is we are developing. So these are the 6 components, and each and every component is scheduled for a community preview from next year onwards. So this is something that we are coming up as a community project. Now, working with this, and more than a year, we have gone through lots of phases, because we knew that we need to achieve this. We knew that these are the things that we need to do, but how to do and where to involve other people and other members of the community was one of the key aspects that we wanted to understand. So the first thing that we have gone through is, because of the project was given us a chance to have a team with us. The team is right now in the talk, so everybody is right now listening to this talk also. So the team has actually and we have developed these components, and after whenever we were developing these components, we thought of sharing the code base and extending the team with academia. And then the idea of a iPhone research network came into existence. We had 3 objectives over here. The students, faculties interested in open source projects, if they are interested, and students and faculties if they are interested in research, and the campus infrastructure can be used to host servers and measurement endpoints. These were the 3 major objectives that we thought that we can share and we can extend the arm. So the first thing that we have done is the complete secured open source collaboration platform. So using the servers of the project and all the private cloud infrastructure, we have built up a secured open source collaboration platform, having completely DevOps implemented. And the guy, if a person from any of the university wants to, if we want that that particular person can be involved in our team, so we have internal Git repository, we have Jenkins implemented using a VPN, and we have implemented Jitsi Meet. So using this, we are collaborating with the universities. They are actually using our team members are educating them or mentoring them using a particular problem statement. And the person, whenever they are developing, it is developing in our servers, and it is an internal Git repository where everything is getting developed, and it is built using a complete framework. So that particular framework is running, and gradually we are extending the this particular problem statements to many universities and many students who are actually gradually collaborating. The second thing that we have is iPhone Internet Research Collaboration. So there are lots of PhD aspiring students who are doing some and want to do some work on research implementations, but they don't have ready-made data, or they want to have some data for their measurements. They don't have that. So for that, what we are coming up with the AORI research portal. In that AORI research portal, all the DNS servers, the Anycast DNS servers, and the measurement network that we will have, this will be a key web portal which will be for the researchers. They can use this portal to download the data and can like one of if anybody is implementing an IoT network or some other kind of research work or some other kind of projects, and they want to test the latency and other features, whether it is important for the particular area or that for the particular network. So this is a research portal which is actually combining the efforts of that anchor network, which is an edge network we have around in this project. We are having 500 to 700 anchor points we are deploying. In those anchor points, this particular data points can be accessed as well as it can be researched. The team is working on different machine learning technologies to have fine-grained information and digging the knowledge about the health of network infrastructure. So these artifacts will really help the researchers to aid in their research at the network layer. The third thing is server and measurement infrastructure. Any university who wishes to join us, if they can lend or they can help us with the server and measurement infrastructure, we can replicate these edge networks over there. Some of the networks, like Suresh has talked in the conversation, that the complete scenario is moving towards containers. So this particular project is completely made using container technology. Each and every component is in a container, and we are using both of them, Docker Swarm and Kubernetes, in this particular whole framework, and so that all the CDNs and all the components can be implemented anywhere, and in an Anycast facility it can be accessed through different nodes. Right now there are two institutions who are actually working. The students are young, talented, and we can see that these are the very innovative works, and they are very much interested in working with this. So MCQ Institute of Engineering, they are working on offensive web services testing. So some of the students are we have engaged for cybersecurity testing of these applications. Testing trace route measurement through remotely deployable distributed devices, RD3. We say this these devices, which are actually edge devices, are remotely deployable distributed devices, and some of the students are working on that. Some of the students are working on cryptographic implementations. Some of the students are working on experimental mobile app version of the measurements. like from Care University, a student is working on practice on WebSockets, REST API, and MQTT. They are present, and two other institutions just joined our research network, and there are three institutions that the talk is in progress, so they will be joining us. So we are actually having in next year plan to have many such internet research network points or points of presence in different academic environments. And after the complete infrastructure is built and the complete research framework is built, we will be in a very good situation to do some kind of research that we have envisioned to carry out with the help of these guys. One of the key aspects of this particular project was to also fostering open source movement, and all the source code and all the artifacts that we have developed will be open source, and it will be available in India Internet Foundation GitHub account. And there is a complete framework that we are trying to implement, wherein for internet measurement, DNS, and other stuffs, if anybody who wish to create or who wish to use these particular open source projects for their own need, they can easily use this. And if anybody wish to contribute this, then it is very easy to contribute, and there will be a governance mechanism for source code repositories who can actually commit over here. And then we are formalizing this in the meantime, so that whenever we are on the public release, we know where to find good contributors, as well as how to enrich these things. One of the key area, because it is coming out from a community initiative, is kind of
Anand, this is Anupam. I'd like you to make it a little fast.
Okay, thank you, Anupam. So one of the key areas that we are actually trying to address is, because it's a community initiative, so go forward with something open source, as well as involve community and get the feedback from community to enrich the things and carry it forward. So achieving this, we are completely these all the components and artifacts which are actually being developed is plug and play. So any other research network or any other internet measurement network, it is very easy that we can have an adapter where we can actually adapt to those networks also, and we can talk to them using API interfaces. So this is all about the initiative that is being carried out at the research level in India Internet Foundation. Over to you, Anupam. Thank you.
Thanks, Anand. So, any comments, questions from any of the panelists?
Anupam, do you hear me?
Yes, I do.
So I have a quick, maybe it's not really a question, more of a suggestion. So, and this is something I think I alluded to Abhijan privately. So in Europe, and also to some extent in North America, we have this consortium called EduRoam, which is basically some kind of educational roaming network. And the idea is that all the universities that are part of this roaming agreement or federation, if I visit some other university, I should be able to use their Wi-Fi infrastructure. And Wi-Fi is more of a necessity rather than like some additional feature. And most of this EduRoam network is based on like IETF standards like EAP and Radius and so on. And a lot of like servers are already available, like free Radius. And I was thinking, now that you have set up this university network with at least some initial universities, like you could be then the pioneers of starting the EduRoam equivalent in India, like get this network up and running, where students from participating universities can actually roam and use Wi-Fi. And if you are the ones who start it, then you will be in like the key positions, and everyone else has to then come and pretty much, depend on you to like get the agreement set up. Of course, they have to set up their own servers, which they anyways have. Like any university these days, they provide like some kind of a username and password to their students. But yeah, I guess this is a suggestion you can think about. I think like it's not too much of a cost or development effort, especially like because a lot of this is like available as open source and non-standard components.
Yep. Thanks, Mohit. I think we will take back this suggestion very strongly in our plan of action, and you'll get some kind of report from us that where we have reached on it. So thanks for making that comment. Thanks, Anand, for letting everyone know about the iPhone Research Network. With this, Mohit, can I ask you to come in and talk about the IETF?
I thought Abhijan goes before me. Abhijan, do you want to? Was there, at least on the program, it said?
Yes, I think.
Abhijan, I don't mind. Please go ahead if.
Yeah, I mean, basically, we are trying to compete with the time, and that is why I said that it is better that people get the idea of ITF. But Anupam, I can briefly tell in maybe within 5 minutes. I close if that is okay.
Okay. So we'll keep everyone happy. So
let me share my
yeah,
screen. Yeah, just give me 1 minute. Yeah. Um, I hope you are able to see my screen right now.
yes, I can. Yeah.
Yeah, sorry. So, we have been talking about protocols, and ITF is something which is at the aim of affairs in designing protocols. And why we wanted to speak about this is while we see that there is a very, in terms of contribution from India, I mean, in terms of indigenous contribution from India, there is a lack of awareness and also lack of contribution, although we are one of the largest consumer of the internet infrastructure. So we just wanted to speak about one effort that happened about 4 years back, and I was fortunate enough to be part of that. So this is basically on IoT protocol. So if you search with RFC 7967, it is basically an extension to an IoT protocol called QAP. So let me just briefly give you the background. So I basically work for TCS Research in Kolkata, and we are working on optimizing the IoT communication for constrained environments, constrained devices, and etc. So we are trying to see what is the best possible approach. We are given one solution for a bus tracking kind of system in one of our offices, and we try to, we found that there are a lot of problems because they are still using HTTP, and that is I'm talking in back in 2011 and 2012. And we found out that what was the problem, and the battery, the car, even the bus, the battery of the bus was being drained out because of the sensors they had deployed and the communication that was happening. So we started to take a step-by-step approach, and at that point of time, constrained application protocol was being designed. It was, I think, the draft was at version 3 or something like that, and already some implementations were out, and we tried to play with it. And I don't want to go into the details, so maybe your teachers and the students themselves can actually get into it and learn about what web does. Basically, it does the HTTP like web browsing for sensor devices or constrained networks. So the idea was that how you can optimize the communication model so that all the GPS update and sensing, so whatever is going to the back end can be done at a cheaper cost in terms of communication and resource usage. Um, so without going into much details, this is the test setup that we did, and this is the interior. You're seeing the interior of my car. So we deployed all the sensors. You can see the sensor on the dashboard. And that time, luckily, the dongles used to provide us with, public IP, the Tata Photon dongles back in 2012, 2013. And we deployed in the system. And with Warshak, we kept on, observing what is going on. And what is known today as Bishwabangla Sharoni, which is the main arterial road from airport to Sector 5 and to heart of Calcutta. On that was, we used to drive through different times of the day, and we used to collect data and see whether how the existing HTTP based system is performing and how the co-op based system is performing. And while doing that, we found that we can further do some optimization, because in certain cases we can modify the interaction so that the data can be the amount of exchanges can be reduced. Maybe so. Basically, the idea is that telling the server that, boss, I want response for this data, or I don't want response for this data. So that is how it is called no response option. And while we started doing this for GPS system, this got a lot of traction from lighting industry as well. And you can see that this RFC is being mentioned in some of the lighting industry standards. Earlier it was mentioned in Fair Alliance, that is a standard for lighting industry, but now I think it has been mentioned in they have moved to some other alliance right now. So the use case was that if you are doing over IP, if you are doing a multicast, and you want to switch many lights or many appliances in a smart building, so there should be a debugging mechanism at the application layer itself, so that you can select how many responses you want back, because that can actually melt down the system if there are too many responses from, say, a lot of appliances that you want to run. So you can always go through this RFC. So connected lights and LP1 is also finding some mention. And this was my journey. Mohit has become my friend since Paris IETF meeting in March 2012. If I am not wrong, that was Mohit's first IETF as well, and my first IETF. So from there we actually had to go a long way, and I'm thankful to my company for sponsoring all those travels. And I'm also thankful to ISOC, because I don't know whether it is continued, but at that point of time ISOC used to used to ask nominations for technical fellowship for IETF. And there were 4 times that I managed to get the fellowship, and they were critical times, because in those meetings I had to actually stand my point and answer the reviews face to face. It was a great experience. I can talk more about my experience later, given an opportunity, but let us hear about what really IETF is. That's it from my side, Anupam.
Thank you, Abhijan. Any comments, questions for Abhijan? So I'm sure there will be some questions, and we'll connect on them later, Abhijan. So moving to Mohit. Welcome, Mohit, once again for this talk on IETF. We do have a lot of students and faculty members and people from the academic community. And this is one particular community in India which is still not entangled, if I can say so, with the IETF processes. And that is pretty much evident if you reflect back on the presentations today as part of PhD Forum, the papers, there were some questions which were left unanswered when it came to the network layer. So, and that is where primarily the IETF is working. So, over to you, Mohit, to give all of us some sense that how can we get engaged in the IETF processes and what does it mean to get engaged. Over to you, Mohit.
Okay, do you hear me fine?
Yes, I do.
And how about the slides? Do you see them full screen?
Full screen, yes.
Yeah. Excellent. So yeah, I think thank you for this opportunity to present, and good to see so many students and faculty members. Also, it was good to see Suresh. So as Abhijan said, that when we participate in the standards meetings, we make friends because we travel to these meetings or used to travel to these meetings before COVID. And Abhijan was right that both of us met each other in 2012 in Paris. And both of us had our first IETF experience back then. He then was coming a little bit more regularly early on, and then I was not going as often, and later on I was going more often, and he was busy and doing lots of other things. And same with Suresh. So Suresh has been kind of my mentor and role model. So he was working for the same employer, and he was this senior area director. But like what was really nice is that he's very welcoming. So if you send him an email, unlike lots of other people, you do get a response, and he's always there to help. And actually, the first working group that I was chairing was he was the area director for that. So you build these friendships and connections over a standards meeting. So it's not just fighting about technical stuff, but you make good friendships as well. So yeah, I work for Ericsson in Finland, and I'm a research fellow at Aalto University in Finland. If you wonder how did I end up here, I will quickly tell you like what do I do and how did I end up here. So as said, senior researcher at Ericsson, research fellow at Aalto. I've been in the past at Carnegie Mellon. I have a PhD degree from Aalto University. And how did I end up in Finland? Well, basically, European Union has these fully funded scholarships where they provide scholarships for you to like study and live in two countries. So it's this Erasmus Mundus scholarships. And if any of you here, I wonder if any of you are doing your bachelor's or maybe know your friends, brothers, and colleagues who are now finishing their bachelor's to encourage them to apply for this program because they literally pay for everything, your rent, food, all sorts of expenses, even like your flight tickets to travel from India. So when it's fully funded, it really is fully funded. You actually end up saving more money than you can spend because it's like a fixed stipend that you get every month. And it's sufficient. So I was 1 year in Sweden at the Royal Institute of Technology and 1 year in Aalto University. So what do I do? Mostly applied network security research. I also write code. I don't do formal modeling myself. My colleagues do, but I understand them to some extent. So obviously, if we have some discussion, I need to at least follow what formal modeling challenges there are. And these days, if you like come up with a new security protocol, it is quite typical that it's a requirement to also have formal models proving that it's secure and doesn't have issues with it. I'm fortunate enough to be chairing or co-chairing technically because there's generally every working group has two chairs. So I'm co-chairing the lightweight implementation guidance and the EAP method update working groups. Of course, as a PhD student back few years ago when I was still a PhD student, I was a part-time PhD student. I was still publishing papers and was lucky enough to get a couple of best paper awards. And in Ericsson, we also do lot of IPR and patents. So even though this number looks a lot, there are people who do way more than this. So I am sure you have seen that Ericsson had like some patent lawsuits in India and got lots of money from certain people, and then the same is with Samsung or Apple. So we spend a lot of money in R&D, and then we try to collect it through patent royalties. I should have said that this is actually the last presentation, so I'm like in a tough spot to keep you awake. I'm sure it's dinner time or maybe bedtime for some of you. So I have tried to keep like some entertaining parts in the middle, and feel free to ask questions whenever you feel like. So what is standardization? And before I talk about IETF, I thought like it's more important to discuss like what is standards, why IETF, why should you even do standardization? Uh, that's some question maybe we don't think about initially, but are also important. So, well, standard is basically a set of rules that a group agrees to follow. So, if we are now communicating in English language, you can think of that as a standard. There is verbs, nouns, pronouns, and we all have a common understanding and can communicate with each other. And the same if we require devices on the internet or any network to talk to each other, we need to kind of agree on something, and this something is then the standard. You can have standard protocols like TCP, IP, TLS. You can have standard languages. Of course, English is one example, but closer to computers you have JavaScript, C++, and so on. And then also for data representation, so UTF-8, ASCII, and so on is something we all kind of know exists, but these are standards that some people met and agreed to and wrote it down in a document, and that's why we can actually communicate and interoperate. What's the need for standardization? So I have covered some on this slide, and then some I will just mention, even though they are not on the slide. Of course, interoperability is kind of standards are necessary for that. You also want like modular software. So if you have like a standard layer 2 and you can build something on top of that, it makes things easier. So one example is, IEEE does the 802.11 standard, and then IP, which is done by IETF, works on top of that. Similarly, like IETF builds the HTTP standard, and various other companies build services on top of HTTP. It's good for scalability. So if you have like a public standard that is available for everyone to read, they can also implement and start deploying stuff. So if you really care about, global reach, that people in other countries should also be able to use your work, standards help. There's like lots of people who will say that this is to prevent vendor lock-in and it increases competition. So if there are many companies that implement the standard, a customer can choose from any of them and you don't have to depend on any one. What maybe some people won't tell you, it's also about money. So this is not true for IETF. This is mostly true for 3GPP, that if you like have some idea, you get a patent on it, and then make sure that this idea becomes part of the standard. And basically everyone who implements this standard then has to pay you royalties. So this is maybe more of how 3GPP works. Not all standards bodies are similar in this way. So IETF is, maybe it's not as common to see patents on IETF contributions. So some entertaining part now. So I hope you are not completely dozed off. So obviously, like many of you are PhD students, faculty members, and like the obvious question is like, why should I work with standards? And you could say that because my professor or friend or colleague says so, or maybe Anupam or Abhijan said that, yeah, standards is great, so maybe I should do standards. And maybe there is funding available for standards. So I have this project that is funded by the government to work on standards, and maybe that's why I should do standardization. And that's a very good reason. I think like there is very good motivation to have good salary. So I'm not saying it's bad justification, but hopefully it's not the only justification to work on standards. And I'm sure for most of us, we have more the reasoning for doing something than just it pays my salary. Another reason you could think of is maybe it's more prestigious. So is it so that if I get a RFC against my name, I can brag more to my colleagues? So I actually yesterday evening spent some time looking up how many RFCs are roughly published every year, and it varies between like 150 to 350. So last year the number of RFCs in 2019 was exactly 180. So this is an exact number. And then I thought, how can I compare it with like research publications? So there was some figure that was saying there's more than 2 million research articles published, but that's not like a fair comparison because a lot of medical journals are publishing research articles as well. So I would like to compare it more to like computer science research papers. So I took one journal, and this is the MDPI Sensors journal, and counted the number of articles published in this journal in last year. And just in 1 year, it was 5,581 research articles. So you might think that because there is fewer RFCs published every year, then maybe research publications, if I get a RFC against my name, that's more valuable, or I can brag more about it. To some extent, maybe that's the case, but I don't fully agree. So one thing to remember is that more doesn't necessarily mean bad quality, and less doesn't necessarily mean that it's prestigious. So you will have like everything in all places. So if you like try to publish in some of the top journals or conferences, their acceptance rate would also be quite small. So you could say that they are more prestigious than RFCs, or then you could say like there's so few RFCs that maybe they are more prestigious. So no, I'm not saying that this MDPI Sensors is a bad journal because it publishes 5,000 papers. It's actually, if you look at the statistics, it's highly cited, and whatever, if you care about this H index and impact factor and so on, it actually has quite good ratings. So of course, if you pick this journal, there will be some very excellent papers and some not so excellent, and the same is the case with RFCs. So you can even find RFCs that are like 1 page long and are just fixing some minor URL or something else. So not everything is black and white. So that's maybe not completely true that I should work in standards because they are more reputable. The third maybe reasoning is maybe it's good for my career, so I'll be able to get jobs. To some extent, maybe. Depends what kind of a career you want. So if you want to work in the industry, in certain industries and for certain companies, they obviously look for experienced standards people. So if you have some experience of standardization, whether it's IETF or 3GPP, that helps. Of course, if you want to go into an academic career and like are focused and know that you want to become a professor, it's still nice to have, but I would say a lot of universities don't consider RFCs as peer-reviewed publications, even though IETF RFCs are heavily peer-reviewed, and it's actually quite tough to get an RFC. But like at the end of the day, if you're applying for tenure track or something, they really focus on where you have been publishing and your citations and so on. So it's again like not black and white that working in standards is good for my career, but it doesn't hurt. So even if you're a professor, it looks good that yeah, you're integrated with the standards community. So why should I really work with standards? So industry needs standards experts. So if Anupam and Abhijan are asking you to work in standards, it's actually a good thing because it increases your employability, at least in certain industries. So they are asking you to do a good thing, especially if you in future see yourself in an industry track career. Um, it's also like maybe like if you write a RFC of your research work, it will get deployed, like more people will start using it and everyone will start implementing it. But it's again unfortunately not true, and I have learned it from personal experience that once you publish a RFC, that doesn't necessarily mean that suddenly the whole internet starts using it and everyone starts deploying. So I'm speaking from my own failures and giving you advice. So how should I get my research in real products and to real users? So I think the golden standard is like running code trumps all. So it's important that you have like, implementation, but it's not sufficient to have like a prototype implementation that works on my laptop today, but maybe not tomorrow on someone else's laptop. So it's when I say running code, it actually means really good quality running code. So it should be at such a level that if I want to try your new protocol, I should just be able to do sudo apt get, install some package and then experiment. And then if I like your protocol or it solves some problem, then I will actually make the effort of, investigating more. And I have, again, speaking from my personal experience, I have been working on a protocol called DeepNoob for some years now, and it's open source and on GitHub. It's implemented on another open source library, and unfortunately, none of us have the time to actually maintain the repository, and you will constantly get like questions, oh, it doesn't compile on this platform, or I want to implement this feature, and there is no one full time who is then responsible for maintaining the code. So that's always a challenge. And if you're really driven by getting your research deployed, I guess having open source high quality code on GitHub is the way to go. Just writing RFC will not help you, and actually like implementing helps in writing RFCs. So standards are good for like getting technical feedback. So if you write a draft specification, you'll get lots of technical feedback. It's obviously good to build on standards. So you don't want to like build like something from scratch, because then no one will ever bother to deploy it. Another trend in the networking industry you can see is like things are moving more and more in the application layer. So if you look at Quick, which is the protocol that replaces HTTP and TLS, kind of combines them. Quick is actually working on top of UDP. And the reason for that is that TCP and UDP reside lower in the stack, in the kernel, and development is much slower. So moving things to the application means like I can quickly prototype, experiment, and ship. And Quick builds upon then this UDP standard. You can also gauge industry interest. You will also learn how to write precisely. So if you have written a research paper like me, I think sometimes it's so easy to write in a research paper that it's, you can compute the hash over something. But when you actually write specifications, you really have to precisely write like hash over what inputs, how many bits and bytes are in the input, and how many bits and bytes of the output are then used further on. So that like polishes your work, but also makes you learn how to write precisely. You can detect interoperability issues. So one thing I have seen at the IETF is if people review your drafts, they will give you so much feedback, and so good feedback of things you had not thought about. Simple things like character internationalization across countries and languages, and why certain UTF encodings work and why other encodings don't work. So for example, I'm a complete noob when it comes to encodings, and then when someone at Microsoft reviewed my document and gave like a bunch of comments, and I was like super impressed. Like I had not thought about those issues. And of course, like wider reach and global audience. Something I forgot to mention, why companies also are interested in standards is because if it becomes a standard that other companies are using, there will be more people working with that particular technology, and they can like then hire more, they will have more workforce supply. So that's some kind of tertiary benefit, maybe not exactly stated for standards. Otherwise, I mean, there are many benefits of standards, but these tertiary benefits are maybe not as often highlighted, is that it reduces the cost of things. If there is like an open source standard and open source implementations, then for the company, it reduces the cost of, rather than maintaining it in-house, now there is a community that is working on these tools and libraries. So I see now I have like maybe 10-15 minutes, so I will kind of go through the rest of the presentation a little bit more quickly. There's like many standards bodies and industry consortia. IETF is definitely not one of them, and each of them is important in their own domain. So IEEE, 3GPP, GSMA, they are all important and are used in different places. IETF is then the body that does core internet standards. So you all use IETF standards on a daily basis. There's no question about that. If you have a phone in your pocket, you are using some of the IETF standards. IPv4, IPv6, TCP, UDP, TLS, these are like the popular ones that you are using. How is our IETF organized? So there is like a IETF chair, and then there is area directors, and you have these areas. There's the general area, application and real-time, transport, internet and routing. Then operations and management and security are kind of also areas, and these areas are run by area directors. So you had seen this presentation from Suresh. So Suresh was the area director for the internet area. So he was very active in lots of the IPv6 specs. As he showed on his slide, he has more than 35 RFCs. So really great standards person with tons of experience. There are more than 130 working groups. So if you have any ideas, I'm sure most likely there is a working group active in that area. There are certain situations where you have some new research work for which there is no appropriate working group, in which case you can always start a new working group, but the process is a little bit harder. It's easier if you already have a working group set up and then want to contribute something. Most of the work is done in mailing lists. So even though we travel to the meetings, which are 3 times a year on 3 different continents, most of the work, or actually all decisions, are confirmed on the mailing list. So even if you are unable to attend a meeting, you can always give your comments on the mailing list. Of course, from personal experience, and I'm sure Abhijan would agree, that if you really want to publish RFC, it helps you to travel to the meetings. And I mean, in COVID, we are not traveling, but I still believe in future, maybe we will have fewer physical meetings, but we would still need some of them, just because it like makes it easier to know people. And in standards, I would say half of the work is like knowing the people. The rest is the technical work. Most of the standards work done by working groups, and it's a voluntary standards development organization. So basically, IETF doesn't really view me as an employee of Ericsson or Abhijan as an employee of Tata. They just view us as individuals who are then contributing to make the internet a better place. Obviously, the reality is a little bit, again, not black and white. So sometimes what I am working on in the IETF is obviously has to be beneficial to Ericsson to some extent. Otherwise, why would they pay my salary or pay me to travel to the standards meeting? So I work in like the directorates, review other people's things as a volunteer, but also then drive some of the things which Ericsson wants to standardize. So maybe the important thing from this bullet is that there is no like voting. And the reason for this is that if you really had voting, companies like Ericsson and Tata can send thousands of employees to one meeting just to vote. If they have some really important thing they want to get through or standardize, they don't mind paying 1,000 people to fly to US and vote for some meeting. So they absolutely didn't want any of this voting, and which is why it's like everybody is an individual, and I will have on the next slide, we don't do voting, but what is called as rough consensus. So yeah, as I was leading into this slide was that IETF says we reject kings, presidents, and voting. So you don't have like, oh, I presented this idea and let's vote up or down. Instead, it's rough consensus and running code. And rough consensus is basically like, obviously, you can't make everyone happy, but you have tried to accommodate pretty much everyone in the room. And there is always like some RFCs are published even though there was someone opposing in the room, but you try to come to some sort of a consensus. You are, as said before, identified as an individual, not as your organization affiliation. And actually all the selection to the leadership positions like area directors and the role of the chair, IETF chair, is all done by a NOMCOM, nominating committee. And the nominating committee is actually basically anyone who is attending IETF is randomly selected. So I was serving on the NOMCOM, and that was an interesting experience that you actually interview candidates for the leadership positions. So it is in true sense a democracy that randomly 10 people are selected from those who are participating at the IETF, and then it's up to them to decide who will lead them. So it's some sort of a democracy. Of course, like, nothing is perfect, but it's the best system we have. If you ever go to IETF meetings, you will hear a lot of I-related organizations. So IETF is one, and there's several tightly coupled or integrated organizations that start with the alphabet or letter I for the internet. So there's the Internet Society, there's the Internet Research Task Force, which is the sister organization to the Internet Engineering Task Force for more research-oriented things. So if you're a PhD student and have maybe more like a researchy idea that isn't ready for standards yet, you can also take it to one of the IRTF working groups. There's the Internet Architecture Board, IANA, Assigned Numbers Authority, and IETF and IRTF are led by the steering groups, corresponding steering groups, which is the IESG and IRSG. There's also ICANN, which is responsible for assigning domain names for regional internet registries and IP address assignment. And I have on the next slide. So on the right side, you see ICANN, and which is then like oversees the work of IANA, and IANA is giving like protocol numbers. So on the leftmost side, you have these numbers. So if you think of port numbers is an example, if you want to reserve a port number for your protocol, you'll have to contact the IETF and IANA, and basically IANA is then overseen by ICANN. There's the regional internet registries, again through IANA, overseen by ICANN, and the domain name is directly handled by ICANN. On the left, you see a little bit of the hierarchy of how the IETF is. So if you actually then see in this diagram, IETF is kind of a small entity in the larger hierarchy of things. Yes, I hope you all know what is an RFC. This current RFC number 8,000 is from really long time ago. I think now we are at 8,900 something. So sorry for that typo. Not all RFCs are equal standards. Some are informational, experimental, best current practice, historic, and a few RFCs are actually unknown. So what really good thing about RFCs is that they are like completely open source and available for free online on the internet, unlike some of the other standards where you will have to pay to access them. So that's another reason why IETF standards are so successful, is basically anyone can read them without paying a fee. Otherwise, it becomes an obstacle. I think many standards bodies are now moving towards this trend of making their standards at least available for free for other people to review and implement. What does the RFC life cycle look like? So if I have some research idea, what should I do next? You should write a draft, and obviously Abhijan and I and Suresh and all of us are there to help you. Then you present it in one of the working groups, you get feedback, and this is like a constant cycle that goes over several years. So one thing you should remember is, unlike conference publications, standards are much slower process. for many reasons. So if you actually are able to publish RFC in 1 year, that is like record time. Generally, as Abhijan showed, it takes 3 to 4 years for things to get published. I mean, there are RFCs that are published in 1 year, but then they are like very small additions rather than like full-blown protocol specifications. So you present and you get feedback, you present and you get feedback. There is then call for working group adoption, where it like officially becomes adopted by that working group. And again, you go through this cycle of feedback and update and feedback and update. Finally, when the working group thinks that it's ready for publication, it sends it to IESG, which is the steering group that then makes actual decision whether this should be published as RFC or not. And in most cases, when it's sent to the IESG, they will have like lots of comments further to improve it, but it's very rare that the IESG says that this should not be published as a RFC. So some working groups, I have highlighted some of the core IoT working groups here. I won't go through what each of them is, but these slides hopefully I will send the slides to Abhijan, Anand and Anupam, and they can share it with you. But these are some of the important working groups. There's also secondary working groups that are relevant to IoT. So there's the Crypto Forum Research Group, T2TRG, which is the Thing-to-Thing Research Group. There's drone remote identification protocol. So if you think IoT also includes drones, and there is work on drone identification in IETF. Home networks, how to automatically assign addresses and names to devices in home networks. OAuth, I'm sure some of you have heard about. I think I tried to stop here. I had more slides on like what these working groups are doing, but maybe I stop here, and if there is some questions, feel free to ask. So the rest of the slides are just going through some of these IoT working groups and telling you what they have been up to, but you can also look this information online. I don't want to, keep you much longer here. So yeah, Anupam, up. Yeah, question.
Thanks, Mohit. Really nice presentation. Thank you.
Yeah.
Yes, Mohit, great presentation, and thanks for speaking your mind and heart out on this one. So it is important that when people come into the standardization, they understand what they are entering into. So thanks for speaking it out and making it really black and white. So any other comments, questions from the panelists?
So what is the process of RFC selection, or rather RFC filing? Means
so there's as I tried to show in the slide on the RFC life cycle, there is like the normal process is that you first write a draft, and basically anyone can write a draft and actually submit it. There is no peer review before you actually like submit a draft. Once you submit it, it gets like available online as an individual draft submission, and then basically you find the corresponding working group for that draft. And as said, there is like more than 130 working groups. So hopefully for your work, there is some corresponding working group. If there is not, a new one can always be started. The process is a little bit more trickier, but then you present your work in the working group. And if there is interest from, other companies and other colleagues, then it gets formally adopted by a working group. After adoption, you again improve it based on implementations and requests for features from other companies. And then it's sent to the IESG for reviewing, and then finally it's published as RFC.
So it gets the number after that?
Yes, so after the IESG has reviewed and approved its publication, then it goes to the RFC editor queue, where they basically check the language and do some final checks. and then it gets RFC number. It's pretty like random. You can't really choose your own RFC number. I wish I could pay to get premium RFC numbers, but so far I've gotten like 83, 87, 89, 28, 85, 76. So
Yeah.
I don't have as many RFCs as Suresh, so I can still remember them.
But how is
Like
that is
I remember my first one. Yeah, but I think one more thing, Debash, is that's not in this thing, which is kind of also important, right? Like one thing that can hold this up quite a bit is references, because like when you have a reference to like a draft that has not been published as RFCs, it holds it up. So imagine there's like a dependency tree sitting in there. So I know of documents that have been sitting approved RFCs for like 6 years, for example, right? Because they have a dependency on something which has a dependency on something. Like for example, there's something in core, right? Because like, I think Abhijan is working on core stuff. So there's like a document in core that's like holding up stuff for 6 years of all the RFCs that have been done and published, right? So I think like, that could be another piece in the head that's not under your control, but choose your references wisely, right? Because if they're not done, if they're on a lower maturity level than you, then that's going to hold up the publication.
Yeah,
Yeah,
so I think the
just
best
to
yeah, Abhijan, I'll just add that the best
yeah,
example
sure.
of this is the resource directory draft. And I joke with the people in the core working group that when I came to the first IETF, I was actually writing my master's thesis and I was implementing this resource directory. Then I finished my master's. Then I also finished my PhD, and it's still not a RFC today. So it can take really long time. And for various reasons, the authors have moved on to other companies, are busy with other things. There's new features, whatever. But as Suresh says, there can be many reasons why it can be held up. Abhijan, sorry.
So it is
Yeah,
a kind
so
of patent. Patent also takes a lot of time and also similar kind of life cycle.
Right. Well, like it's similar to that, but it's a bit different because like patent is like one person deciding, right? Like, the examiner decides whether you get it or it's held up, right? So like in that way, it's like, think of the references as the citations you get on a patent. You do a filing and the person is going to say, okay, these are the prior art I found, and you modify the claims. But here it's a little bit different because the idea is like everything you stand on needs to be at least as stable as you, right? So you don't want to have like a standard which depends on something that's not stable, right? So the idea is like always like, all your references need to be at least as stable as you, if not more, right? They need to be further along so you cannot like take an experimental spec and base a proposed standard like on or a standards track document on top of it, because the other thing is not stable. So that's really the goal, is to make sure that all the references are stable if they are normatively required.
Okay. Thank you. Thank you very much.
Yeah.
Excellent.
Thanks, Mohit. Just a small comment from my side that in your organization structure, where do you see PTI standing among ICANN and IESG? Or is it just the INA which is closely working with ITF and PTI is something absolutely different? Yes, on this one.
I sorry, didn't follow. Which organization are you talking about?
I'm talking about PTI, Public Technical Identifier. So when you are, so do you consider that as part of ICANN, or is that organization has some kind of influence on IETF?
I don't really know. Maybe Suresh can answer. I think I don't know about this PTI organization. So I'm hearing about it for the first time. Maybe Suresh knows more.
No, not involved. No.
No, I think that is primarily where the INA got, when it got transitioned in 2016. I think they moved it to another
No,
organization.
right. It's just a designation, right? Like, it's
Okay.
more like a change of control than change of function itself, right? Because like the INI used to be controlled by a US government entity, and the idea was like to move it to a multi-stakeholder entity. So that's like what is called post-transition, right? Like, so there was a transition that happened just around the time If I remember correctly, around like, when Barack Obama left kind of time frame, that's the time frame like we're talking about. And that's pretty much it. So like there's no functionality, there's no difference, right? Like it's really the governance that has changed.
Okay, okay. So it is just from US control to a multi-stakeholder community, that transition, what
Correct.
has happened.
Correct. Yeah. Yeah. Correct.
So
Okay. Okay.
I have few comments to make. Hello.
Yes, Abhijan.
Yeah.
Quick comments
So
is okay.
very quick. So mostly related to what Dr. Dey has asked. So one thing is that probably we can, I mean, if everybody is available someday, we can do a hands-on session on how to submit a draft and actually show people that where are the links, and if somebody wants, they can actually motivate some of the students to simply write to some working group on their thoughts and etc, and we can discuss on that. So a hands-on can be arranged, and that will be very easy. And the other thing is regarding the patent and RFC. Uh, Actually, what Suresh has said is very right. And from my side, I can say that when I went to ITF, I came from an organization where nobody actually speaks about ITF. Okay, at that point of time when I came, and it is basically you start, you don't know where from questions are going to come. So as Suresh said, that questions are not going to come from a single person, or from all square, all spheres questions are going to come, and you have to defend. And as Mohit said, that you can't even imagine that this can be an issue, what the people in front of you. So people will actually line up in front of the mic and they will start shooting questions at you, and you have to instantaneously defend. And maybe some discussions you have to take to the mailing list. So it is a lot more hectic stuff in some way. So we can always do a sensitization session on how actually you can create a draft and submit.
Yeah, I can second that. So having presented at conferences and at the IETF, I would say like IETF is a little bit, not little bit, I feel like more, depending on the working group, more aggressive crowd. So in a conference, like I present for 20 minutes, maybe like 4 people in the room are actually listening, the rest are checking their emails. And if I'm lucky, someone will come to the mic and actually ask some interesting question. Whereas like in the IETF, I have been to some working groups where I'm on like the first slide, the title slide, and there is like people at the microphone because they don't even agree with the title of my talk. And yeah, so it can train you in many respects and prepare you for situations in many ways.
Yeah, but that has given a personally I have learned how to choose your word in describing, and it has been a great learning experience, ITF, for me personally, in presenting myself or my thoughts. Yeah.
Okay, okay, Mohit, thanks once again. And now it is job of me as a moderator to thank everyone. A quick vote of thanks to all the people who presented their papers, starting from Darsin Demari, Dr. Mitaba Nag, who wrote the paper together, then Samarjit Roy, along with Dr. Devashish Dey, their paper on inspired music analytics framework on Internet of Music Things, Atanu Majumdar and Dr. Ramlan Chakravarti for their paper on energy-aware real-time scheduling for heterogeneous reconfigurable cloud platform, Anurina Tarafdar for resource management in a cloud data center considering energy efficiency performance, and Asmita Biswas along with Bipasa Mahto and Dr. Deep Subra Guharoy for their paper on blockchain-based decentralized trustworthy network for public healthcare. Another paper by Dr. Deep Subra Guharoy along with Kaustav Kumar Mandal on gateway of blockchain, IoT meets edge computing paradigm. and then Anvisha Mukherjee and Dr. Devashish Dev for their paper on a delay aware green Internet of Health Things paradigm in underage computing. Sorry for that. And finally, Dr. R. Nidhya for her paper on medical wireless sensor network, energy and security challenges. So without these people coming in and spending their time and effort to present here, the PhD forum would not have been possible. So thanks everyone for presenting your work. And I would like to thank the panel of experts, starting from Dr. Amlan Chakrabarti, uh, Abhijan Bhattacharya, Dr. Indrajit De, Dr. Manohar Bhuya, Rishabh Barua, and Dr. Devashish De, along with Mohit Sethi, for making it to the panel of experts and spending your time and energy for giving comments and suggestions to the people who are presenting their work. It is always to get a well-rounded feedback, and I'm sure it has been a learning experience for our presenters, and you also would have come to know about what kind of work is happening here and how to take things forward. I must apologize on behalf of meeting organizing team that we could not give a break. We slipped in between around 7 to 8 minutes, so we just avoided the break and we continued with the talks. Thanks to Suresh Krishnan for his talk on 5G and the edge, building the infrastructure of the future. It was very enlightening to understand that how edge is going to unfold in the future. Thank you, Anand, for your talk on iPhone Research Network. This is an initiative by India Internet Foundation, and we hope to take it further uh, under your leadership. Thanks, Abhijan, again for your story of RFC 7967. This is one thing which is keeping all of us inspired to work in the ITF process. And finally, a very heartfelt talk by Mohit. Your talk on ITF, I think in a long, long time, I have heard something with so much clarity and so much black and white. So uh, thank you for your heartfelt talk. It was lovely having you in this meeting. And regularly, if you are giving a vote of thanks, you give vote of thanks to the meeting venue people as well. So I think from that standpoint, we should thank Zoom today, because Zoom has enabled all of us to have this meeting. And finally, my team at India Internet Foundation, who has done a lot of background work in making this happen, starting from the designer Subrajit and other people in the secretariat who have made it happen. And thanks, Abhijan Anand, for all the great work which you have done. And it was lovely having you all. And I'm at the end, and we conclude this second day of ITIPS 2020, part of India Internet Week. Thank you, everyone. Have a wonderful day, evening, and night, whatever is ahead of you. And very happy New Year 2021. Thank you.
You.
Thank you so much.